Going up. Okay. Yeah,
Mhm.
good morning, good day. And I think we are streaming live here about 15, just a few minutes until I think the launch window for the SpaceX's integrated flight test 3 for the window opens up, and we're definitely within the hour of a potential launch. I'm Robert Jacobson, and I got my partner Keegan Kirkpatrick. We're with Space Advisors, and we're here to enjoy this. Hopefully, this successful flight with you. No matter what happens, it should be fun. So I'm going to double check a few things in terms of our audio. Hopefully, the audio is coming through fine.
And in the meantime, just a quick mention, this is, I believe, still set as a 110-minute launch window that should kick off roughly at 7 a.m. Central Time.
Keegan, it looks like we are
We're on. Good.
yeah.
Well, if no one got that little bit of a pretest, I'm Keegan Kirkpatrick,
And I'm Robert Jacobson,
and we are
and
Space Advisors.
we are here with you live today to hopefully enjoy with you SpaceX's their third attempt at a Starship flight test of their Super Heavy booster.
This will be about a 110-minute launch window, beginning officially at 7 a.m. Central Time. For us over here on the West Coast, that's about 5 o'clock in the morning. And we will hopefully be seeing Starships. Are we on S-28 or S-29 today? I can't remember which. Hopefully be making it all the way to orbit and knock on wood, a successful reentry and splashdown in the South Pacific.
Oh, Mr. Keegan, I'm going to maybe for starters, why did SpaceX go with this, the steel design, using steel as metal for the majority of the rocket?
Well, SpaceX originally had attempted to build Starship entirely out of a composite frame, similar to their Falcon launch vehicle. Stainless steel is significantly cheaper, for one, and for a vehicle of this scale, there's a lot of manufacturing infrastructure that is already in place with a lot of knowledge that already exists that they could recruit and stand up manufacturing very, very quickly. It is just easier to iterate on when you have a material that doesn't require a giant composite oven to build and test everything out in. This is why SpaceX has been so open in the manufacturing of Starship, literally. With stainless steel, you can build most of this stuff in semi-covered shelters like the Starship Mega Bay and assemble everything, largely available to the elements. With that degree of ease of manufacturing for a vehicle that is just carrying so much cryogenic fuel, it becomes fairly easy to stand up the actual manufacturing process and then scale that up. Right now, sources from SpaceX are saying that after IFT-3, assuming there's no issues with the FAA or any problems with the pad, they're hoping to achieve another 6 test flights just in this year alone. And that wouldn't be possible if they couldn't stand up, bigger than the space shuttle size vehicles at a rate of every few weeks with a stainless steel manufacturing system.
So they're thinking they're thinking about a factory-like process to manufacture these, not
Yes.
not a bespoke system once it's operational.
Yeah, and this is something that we in the space business are used to on a smaller scale now. SpaceX has made that, you know, objectively revolutionary process almost genteel with their Falcon line. But for a vehicle this size and with this power, nothing even comes close. I mean, uh, we have nothing to compare this to. Every other super heavy launch vehicle in history has been built, you know, with only a handful of units, designed and over engineered to last decades under every condition imaginable. Starship is designed to be a genuine workhorse. And so this is a machine that will be taking a bit more of a beating, a machine who will never truly be done in its design process. SpaceX has made it very clear that they intend to continue to make iterative improvements well up to and beyond when the machine is deemed flight ready for humans, which that's going to be a few years before we ever get to that. But the reason it's only going to take a few years with a vehicle that was developed under such revolutionary conditions is because they can build, test, fly, and indeed blow up quite a few of these things with relatively low cost and low commitment on infrastructure. So we are seeing a change in the development of spacecraft that is not so much new with Starship, but is just the next step beyond what was already achieved with Falcon 9 and what the folks at Rocket Lab have been working on. And even going back to the older generation of vehicles, the Delta and Atlas lineup from Boeing, it's all that's really changed has been scale. And that is the significance of this flight today. We are seeing a potentially game-changing moment when launch volumes and launch cadence will increase by potentially multiple orders of magnitude.
And what about the with this the integrated flight test today? We're going to see some potentially fueling capability and how that is probably an important key aspect that maybe links between a lot of what's possible in terms of SpaceX's, Martian aspirations, use on the moon, really use anywhere in the solar system.
Yeah, and we still don't have a clear idea of what fueling capability test is going to mean for today. Really, anything is a step in the right direction. No one's ever done any version of this except Orbit Fab has tested this a little bit on a much, much, much smaller scale. No offense to any of our friends over at that company. SpaceX, I don't know. We'll see what the definition of refueling is going to be. Wouldn't shock me if it was anything just as simple as running the turbo pumps in reverse and seeing how they can move fuel between the header tanks in the vehicle once it's in microgravity. To be honest, that's enough. That's all they have to do to be able to just demonstrate some of the basic elements of something that NASA and the military and the private sector have all wanted for decades, but now are finally possible.
And Keegan, we talk about this in an upcoming paper that we have coming out about that the analogy of this to the kind of emerging commercial air travel is not necessarily as accurate as one might think. And Keegan, you're a historian buff. Want to share about your insights in terms of how this where SpaceX could fit in terms of historical analogy?
For me, I am always torn between, historical comparisons are, like you said, Robert, are always a little bit dangerous when it comes to a new piece of technology. So the best way to think of it, and this is still a bit of a stretch, is that the spaceflight industry is kind of where commercial aviation would be if World War II had never happened. World War II delivered one vehicle that really changed the game in a big way, and that was the DC-3, which was, or rather, the C-47 Skytrain, which was the original iteration of it. That was the first truly mass production passenger aircraft. built in the thousands upon thousands upon thousands to make it possible to move troops and equipment between Europe and the US, and could not have happened without the Herculean logistical effort required for a war. The space industry has never had that, thankfully. And we've never had to defend Earth from anything. But as a result, while the technology has continued to advance at roughly the rate that the aerospace industry has for aviation, it has never had to develop its supply chains to the same degree. Where Starship exists in my mind is it's kind of somewhere between the scale that we could potentially see from like those old C-47 Skytrains and something like the original Boeing 707, which kind of set the tone for what commercial aviation would look like for the next, 50, 60 years.
And for those who don't know, the 707 was essentially the first commercial, passenger jet.
Well, not the first commercial passenger jet, but the first one to kind of have the standard architecture that we know today and be built at scale. There had been a few attempts prior to that with a lot of very interesting designs, all of which with either technical problems that ended up grounding them, or more than likely they just couldn't produce them at the rate required to even compete with a lot of propeller-driven aircraft. That's kind of what Starship's revolution in aerospace and spaceflight is no small thing, but the significance of it, from my mind, has always been what it can achieve in terms of scalability of production, which, again, that has been an iterative process up until this point, where we've had a few dozen to maybe 100 vehicles built in a company's given roster. SpaceX has gotten to a point to where they can now launch, multiple times a week and barely anyone bats an eye, and then recover the vehicle and then refly it, a few weeks later. The significance of that really cannot be overstated. Robert, I was just thinking the other day about just how even I have gotten jaded about that at this point. It's gotten to a point now where, I was a kid, anytime something was going into space, true space geek like me would drop everything and start watching. But looks like they have pushed back the start of the window to 5:29 a.m. So they will not even be starting the stream until then, by the looks of it now.
Okay.
So you're stuck with us for another half hour.
And then let's go into maybe let's go back. Introduce ourselves. I'm Robert Jacobson, and I'm with Keegan Kirkpatrick. We're space advisors, and we're talking to live streaming today, waiting for the launch window for SpaceX's Starship Super Heavy booster to potentially take its attempt at a flight, which includes, it would be one orbit around the moon. Maybe you'll see a fueling test. I've heard that they've heard that there's three Starship terminals even on the booster, so we might even be able to see some beautiful videos from space.
Just one minor correction on that. One flight around the Earth.
Flight around Earth. What did I say?
You said around the moon. Had they achieved that today? Yeah.
Excuse me. I meant the Earth. But I'm pre-caffeinated here this morning, so
yeah, we are very much in a little bit of a club on that one. Well, the timing of this is actually very apropos because yesterday NASA released their official 2025 budget request for their Moon to Mars manifest, which significant on multiple fronts. First of all, NASA is using the word Mars again whenever they want to talk about human space flight. They haven't done that in a little while beyond kind of just the abstract. They've been moon all the way for the last few years now, which for any younger viewers, That's not new. Robert, how many times have we lived through different administrations shifting priorities about which rock in the sky they want to go to?
Yeah, I mean, there was even a period of time where the space station, it was Space Station Freedom. It was going to be just a U.S. focused space station, not an international effort. Probably wouldn't have.
Yep.
Yeah, I don't think we would have had they just stuck with that. I'm not sure we would see a space station.
Yeah. Well, it depends very much on priorities. Space Station Freedom was originally a far more ambitious design. It was supposed to have like multiple space shuttle external tanks on board for in-orbit refueling and what have you. The end of the Cold War resulted in a shrinking of priorities in space. Uh, so, but what we're seeing now from the 2025 budget request is mainly NASA moving their timeline around just based on practicality. We've known about a few of these changes, like how Artemis 3, which is the crewed lunar landing, has
Keegan, I
been
want
pushed.
to jump in for a second. So folks are not seeing you need to change your screen share options because people are not seeing your slide at the moment. They're still seeing the static image of Starship.
Hang on a minute. That's embarrassing.
Minor technical issue. We can address that. We got some time there. In the interim, for any folks that are interested in commenting, we've got YouTube open also at Twitter, which is our Twitter is Brave New Space Podcast. That's Podcast Brave is where we're at on Twitter or the X platform. And Keegan, I'm gonna do a quick refresh here, see if I can see here. I'm still seeing the static page from SpaceX.
Well, that's odd.
Maybe you need to share your whole window.
I did just share my whole window. That's odd. Hang on a minute here. We'll just have to retry this again. Excuse us, a little bit of technical difficulties. I'm just gonna. All right. I'm just gonna do screen run 1, and hopefully that will go through okay. How's that looking? The picture box is saying that should be up. So
let's see here. Let's see. No, I'm still just seeing your face on the YouTube channel.
Well, drat. That's all right. We'll try the more specific one.
Okay. I think it's working. Yeah, now I see it. It's
okay.
Working.
All right, that's odd. That's probably just something to do with how my video drivers are interacting with a multi-monitor system.
So maybe we could jump back to this this budget request.
Right. So it's NASA has already been kind of forced to move back Artemis 3. That's not to September 2026. That's not news and not a huge shocker. That's not a strike against NASA or SpaceX or anyone. That's just the reality of when you're doing a human spaceflight mission, much less one all the way out to the moon. What you might think of as over preparing is what you absolutely have to do because you really only get one chance to do this right. And if you do anything wrong, even if it's a tiny little thing, there's absolutely nothing you can do, and those problems can compound, drastically, which can potentially cost human life. So NASA has, frankly, no reason whatsoever to defend its practices. They are doing it. So, but we are seeing a couple of other changes here and there. Other Artemis missions have moved around a tiny bit here and there, but we are also seeing SpaceX talking about multiple HLS crewed lunar demos. We are seeing talk about surface activities, integrating other HLS systems into the program, and also moving in some plans for long-term Mars missions, presently robotic, but with NASA that is transparently a plan to go beyond that. And one tiny item on that list, way down there in 3032. In fact, you can see it in the lower right of your screen. The Fission Surface Power demo, which is the small-scale lunar nuclear reactor being developed by NASA and Westinghouse, I believe, which is supposed to be the primary power supply for not just at the moment, just called Artemis Lunar Base Camp, which will be the permanent moon base, but specifically for processing water ice from the lunar surface as a source of in situ resource utilization, which would be the first time ever that's happened on any level. Well, I'm very, very excited about Starship. I've been excited about Starship for a while. And so my excitement now is, as a supply chain guy, is really transitioning to the fact that NASA is talking about otherwise boring logistical level systems that they want to develop for the moon. For me, the most exciting one by a mile was not even the nuclear power source, because NASA and nuclear power on the moon has always been kind of oh, duh, we've got to do that. It has been the discussion and money being put up to do a kind of feasibility study for a liquid oxygen pipeline from somewhere in the Shackleton crater, from wherever a water ice source is, to the Artemis base camp, which would allow them to be able to supply and refuel any vehicles on the surface with local source propellants. Pipelines are always very, very exciting. During our podcast with Colonel Peter Garretson, we were talking in great detail about how the moon, from kind of a geopolitical standpoint, is very comparable to Hawaii, and sort of this what we called the Alfred Thayer Mahanian strategy of building coaling stations throughout the Pacific to fuel the U.S. Navy. So anytime a government organization is talking about using the moon to develop its energy logistics for other vehicles, I get very, very excited, because that tends to be what means that they're planning on doing, not just going to the moon to explore, not just going to the moon to stay, but going to the moon to stay and develop well beyond the limited scope that most lunar programs have been in the past.
Yeah, mute myself. Let me go back to like the landing today. They're potentially talking about a belly flop landing, which will be a unique characteristic of this system in the Indian Ocean. You're not going to belly flop on the moon, but how are they when you're landing on the moon, you're worried about you're going to kick up a lot of dust. What sort of planning goes into that in terms of could you envision for those first moon landings with a SpaceX related system?
Well, they've gone through about 3 different design iterations so far for the HLS. Not huge differences, but what they've seemed to have settled on has been, I think it's going to be something like between 6 and 12 Super Draco, essentially overpowered versions of their RCS system, reaction control thrusters, that will be positioned kind of further aft, or rather further forward of the vehicle, kind of towards its nose, or rather the top of the spacecraft, if you want to think of how it's going to orient itself. And so rather than landing like how the LEM did during the Apollo program, instead of burning from the base, it will burn much more higher up the top of this, 30, 40-foot vehicle, and land with the attempt being to either kick up as little dust as possible near the actual body of the spacecraft. Just because, space has no, on the moon, there's no atmosphere to speak of. The force of those, thrusters is still going to strike the surface and kick up dust, but it'll be far further away from the vehicle and it's kind of spread out a bit more. So it'll be the risk of a debris strike.
Oh, Keegan, let's see. Oh, Keegan, you froze for a moment.
Oh, what was I stuck on? I assume I was making a ridiculous
you just
face.
talked about the debris. You said that there would be a debris strike, but maybe a minimal, be minimized debris strike with where
right. By how these engines can be positioned, it will just be a way to kind of distribute the area of effect on the surface to as wide a point as possible, and therefore less dust will be kicked up overall with less energy. So that's probably going to be the way they initially do it. NASA has going back decades now, made it clear that one of the first things they want to build on the moon with local resources would be a landing pad. I'm not seeing any mention of that at the moment. That technology is still being developed. Incidentally, my company was originally developed from Redworks Construction Technologies, from a NASA feasibility study on that general concept. We refined our technology far away from where they originally proposed. But back in the 90s, NASA was proposing the idea of a nuclear-powered, for lack of a better term, moon Zamboni, ice resurfacing machine, to go over and with microwave radiation, just cook the regolith beneath it into a hard surface, essentially glass, so that when a vehicle landed, it wouldn't have any debris to kick up at all. Which that's a very, very, intense solution to that problem. But really, the solution NASA's trying to solve isn't any different than what any construction or development company has to deal with on Earth when they're trying to clean up what are called, tailings. For mining companies, it's a big problem. You don't want a lot of dust kicking around wherever your construction site is, because while lunar regolith is far more carcinogenic, you just don't want people breathing in dirt if you can help it.
Yeah, well, I mean, I think it's quite sharp, the lunar regolith. They found that, I think some of the Apollo astronauts, it was kind of tearing up the suits.
Yeah, it's, we call it dust, but space dirt regolith. Comparing it to, I've had a geologist explain this to me. Comparing regolith in space to dust would be like calling dust gravel. They're fines. They're extremely tiny, for lack of a better term, shards of broken glass that behave very similar to asbestos and how it interacts with human cells and really any surface. Nasty stuff. And back in the day, NASA was using kind of old-fashioned double mechanical seals on the lunar module. Anything they do on the surface of the moon today is going to be using labyrinth seals, which is how they, or possibly even X seals, which is how they do everything with the Mars rovers. But even they have to deal with dust buildup and damage over the course of many months and potentially years of operation. So clearing up the dust is going to be I'm sorry, I just said it again. Clearing up the regolith is going to be a high priority.
Let's go back to SpaceX's payload capacity. So we've never really had this outside of, I guess, shuttle. It's been a long time since we've had, something that really, maybe if you think of Falcon 9 as like a pickup truck, or and we're moving to maybe more like semi truck, if not maybe a little bigger in terms. I mean,
freight train might be a better comparison, because we're talking orders of magnitude increase. Let's see if I remember this correctly. So the Falcon 9, as a launch vehicle, that has been the workhorse of SpaceX and in practice the entire spaceflight industry for the last couple of years now. And that vehicle is able to for a full throttle Mars transfer orbit, can put something in the neighborhood of something like 4 ton, I think, onto the surface of Mars. But if we're talking for just kind of regular operations to Earth orbit, it's something in the neighborhood of a full throttle can do about 22, 23 ton. That's metric ton, by the way, so around 50,000 pounds. Starship is talking about payload to the surface of Mars of between 100 and 150 tons, and non-reusable version of its upper stage could put something in the neighborhood of 250 tons of mass into orbit. So we're talking an order of magnitude increase in payload to LEO, and order of magnitude times 3 for payload to the surface of Mars. That is,
and with a potential cost that's,
next to nothing. Yeah,
they're talking about under $10 a pound.
Yeah, and that's all guesswork right now, and will be refined just by the nuances of learning how this thing will actually operate, and just There will be a lot of potential additional costs from site logistics to regulatory, regimes that will either have to be adhered to or imposed that we don't fully know yet. And the reason I say that is because, and the FAA will, freely admits that the FAA is right now horrifyingly understaffed and could really use a budget infusion to be able to comply with all this stuff. But we're targeting, something in that neighborhood. And by comparison, Falcon 9 is at below $1,000 a pound. The space shuttle, the Apollo program, those were like in the neighborhood of $8,500 a pound. So we've already seen an order, around an order of magnitude reduction. We are about to see a double order of magnitude reduction.
See, we're potentially about 14 minutes until the launch window opens.
Yep. Assuming no holds, Mother Nature doesn't really care what our plans are.
Yep.
And for that, I will drop our this menu, and hopefully the SpaceX page will come back up.
So again, I'm Robert Jacobson. I'm with Keegan Kirkpatrick. We're space advisors, and if you're watching this on YouTube, thank you so much. We're also on X at Podcast Brave. That is our Twitter handle there. It's the Brave New Space Podcast. And let's see. So I'm gonna check. I'm gonna check the SpaceX feed. So let's just see. Yeah, they're saying weather is 70% favorable.
Okay.
And live webcast will begin 30 minutes before liftoff, which they are now aiming for 7:30 a.m. CT, so Central Time.
All right, so
in Texas. So it looks like things are still moving along.
Yep, proceeding okay. So we'll see. This is a business with, they're called test flights for a reason, folks. They'll, whether or not something goes wrong, mechanical failure, or my personal favorite, something with radio frequency or antennas ends up being a little bit weird, that will get you stuck in the field, sitting on your hands for a while, waiting for the problem to go away, while the software guys try to make sure that doesn't cause any other issues down the line. Refining this technology is going to be the, real challenge for getting to the launch cadences that everyone wants. And SpaceX will eventually figure it out. This is fundamentally just an engineering problem, and engineering problems are great because all you have to do to solve them is throw time and money at them. So we will hopefully get ourselves a flight at the desired time, and if not, well, it's just always good sharing these new ideas with people.
Keegan, there's discussion about using this point-to-point travel. This thing's going to make a lot of noise. I mean,
yeah,
you're not going to be landing this out, even close to the Statue of Liberty. To make this type of system work, given, how large it is, the sound that's going to produce, where on the planet could you sort of operate this from outside of South Texas?
Well, SpaceX and now a couple of other companies are talking openly about creating sea launch platforms. Nothing new for smaller rockets, but very new for a vehicle of this size. There's around 3,000 derelict oil platforms in the Gulf of Mexico right now, a few of them that have been towed to dock, 2 of them owned by SpaceX, in fact, that could conceivably be used for launch platforms. I mean, they already have infrastructure in place for handling a lot of volatile materials. So I could certainly see this being launched offshore to where your kind of exclusion zone just isn't an issue. For point to point, I haven't worked out the physics on this because this is like a decibel calculation thing, and that's not my expertise. You could conceivably do a lower throttle version to take off because you're not trying to go all the way to orbit. In fact, you might not even have to necessarily clear the atmosphere in a few cases. to be able to make that a hair easier. But if you're using anything close to the number of engines this thing's running, I mean, what are they at now? 31. That will shatter eardrums within like a couple of miles, and windows and whatnot for even further out. So for point to point, again, technically achieving it is not the hard part. Gwen Shotwell has been talking for years about how this can be done, and make financial sense. The Air Force and now Space Force are openly talking about this rocket cargo delivery system for troops. It can be done. I'm just going to be very interested to see what the launch infrastructure will look like. It would be, I was just thinking, it'd be the height of ironies here if the Space Force just adds itself as branch number 4 of the armed forces that technically operates a fleet of ocean-going ships. Because while everyone knows the Navy and the Coast Guard, the Army also operates, by number of hulls, technically the largest Navy in the world. It's mostly like tugboats and small landing craft and things of that nature. But it would be funnier than hell if that launch methodology resulted in the Space Force having to operate a fleet of partially mobile offshore platforms.
Checking our window, looks like these things are still a go. No, nothing new on SpaceX's side, which is great. Looking nominal today. So Keegan, what sort of large infrastructure do you see, if you've got this freight train capability to space, to give people a sense of what types, we've always kind of built things in onesies, twosies, they're taking up satellites. They built space station with many, it was dozens of space shuttle launches where, you basically could take an entire station there on a flight or two, depending on just what you're thinking in terms of the mass and size.
Well, I'm not the only one even thinking about this anymore. NASA has released a couple of feasibility studies talking about, the first thing they want, to build with Starship is really just a slightly different Starship that would serve purely as a fuel depot in space to allow for in-orbit refueling without having to. Basically, they want to make the supply chain a little easier for actual, human flight operations, to where SpaceX can just launch their big tanker versions, dock with this thing, refuel it, and then that way they just have something already stuck in orbit that they can, dock with directly without having to just kind of wait around up there for multiple, refueling trips from Starship from Earth. But there's been discussion on building the successor to the James Webb Space Telescope, which would be this much, much larger, mirror they could put in orbit, or possibly even using, again, there's been a lot of talk about using Starship kind of as a wet workshop platform. Now, for those unfamiliar, Skylab was a wet workshop. It was a conversion of an upper stage of a Saturn V fuel tank to be used as the laboratory for actually, hosting and keeping astronauts alive. For a vehicle this big, if you're not concerned about any other payload, you could just make the nose of it a, either removable or deployable shell and stick your mirror inside of the main thing. There's a lot of different opportunities you can work with that when you have just a platform that's this large and this inexpensive and this ubiquitous. Very large space telescopes using this platform also means potentially far, far shorter development times. Because with James Webb, you're out past the orbit of the moon. You cannot be reached by anything. You could conceivably do something to convert maybe a, Dragon capsule with a, tailor-made habitation section and an extra booster to, get her all the way out there. But that's all theoretical. And that would have to be a crash program that NASA hasn't had to institute yet. But for a vehicle like this, when you've got so many of them coming off the line in a given year, again, 6 flights this year is apparently the conservative estimate. NASA has largely confirmed that they think that's practical. You could build a bigger than James Webb's type space telescope and then launch servicing missions to it. In fact, you could build it under the assumption that it's going to be regularly serviced, and you don't have to build it to such high tolerances. In fact, you can build it under the assumption that it's not going to be not just regularly serviced, but upgraded periodically. So you can be a little bit more fly by the seat of your pants in this. I think that's going to take a bit for NASA to just develop the engineering culture to think in those terms, and indeed the private sector as well. We are, like you said, Robert, we are so used to doing things on a small scale. One of my favorite comparisons for this vehicle is it's like going from floppy disks to CDs. The amount of storage space available was so huge in the computer industry when they made that transition. Programmers literally did not know what they were going to do with it all. So I think it's going to be thank goodness SpaceX is planning on kind of a development timeline of going from cargo to crew that would take a few years potentially. Because it's going to take probably that amount of time for us to figure out what the hell we're going to do with this amount of space. The only companies that have talked about that seriously have been a handful of the space station companies that are now coming online. Voyager, Gravitics, all those guys are really looking at a platform like this as saying, oh, we can put a habitat in orbit that can provide 2-3 launches, and suddenly we've got an ISS worth of available space to work with at significantly lower cost. And rather than a 20-30 year development time, it's over and done in maybe a few weeks. So this is a significant change in what can be done. Now that's all stuff that's already been planned. Going back into the archives, I could very easily see, I know Musk isn't as big a fan about this, and that's the only time I'll mention his name. But in-space solar power becomes something you can kind of work as a more practical problem than before. The Air Force Research Lab recently had a successful test of an on-orbit, test article to demonstrate that you can, in fact, acquire energy and beam it in microwaves to potentially be harvested on Earth. And they're now talking about larger test articles. The issue has always been scale. To make it cost effective, you need very, very large arrays. In fact, in the 1970s, NASA was working a little bit with the Defense Department and Rockwell, the now long defunct aerospace company that actually helped build the space shuttle and indeed the Saturn V launch vehicle, to develop a truly ridiculous air-breathing vehicle that would have been, it was called Star Raker, and it was to be able to deliver these huge payloads. And we were talking like multiple flights a day to build these like mile-wide solar arrays. And we're talking 1970s crappy efficiency solar panels in orbit to be able to beam power back to Earth as a solution to the 1970s oil shortage. Didn't end up working out, unfortunately, but with a vehicle like this, with modern solar panels, I could very easily see this, potentially being used to develop a few test articles for that. I figure first customers will almost certainly be either the military or the aerospace industry itself, not just NASA. I could see space-to-space power solutions, where you have a large array in orbit with either laser or microwave beaming system that could beam power directly to other satellites and spacecraft. Advantage there is that you could essentially lease that power as needed instead of having, as a vehicle operator, you wouldn't need to bring nearly as much power systems on board for yourself. You could have a relatively smaller system and just rent or lease, your wattage. Advantage there is that it creates an incentive to scale up that infrastructure fairly quickly, and then can redouble that for terrestrial operations. There's a lot of things you can do with this vehicle. And, we've got, we're working on a white paper to kind of outline how we think this is going to affect a lot of different industries, a lot of operations that have been really kind of coming online very rapidly, that have kind of made us have to really, work on our toes for all this. But You, me, Robert, the whole industry right now, I think we are. This is just the tip of the iceberg of just even the pie in the sky things we're thinking about with something like this. Uh, you
And
know,
so, and Keegan, you've got a lot of there's many small launch companies that are trying to focus on smaller satellites.
mm,
If you have a system that could take a whole lot of your smaller satellites, um, granted, the small launch competitor, the small satellite launch competitor, they're talking about saying, well, we'll launch you when you need to
oh,
go to the orbit you want to be in. Where do you think they fit that fits into like kind of a Starship ecosystem? Do they just ignore each other and say, hey, we're gonna or is it gonna get to a place where there is just where it's gonna be difficult to compete?
just a quick update. They've moved that launch time back another 20 minutes or so. So 5:52 a.m. Is when the stream is supposed to officially start from SpaceX. But to answer your question, yeah, the whole industry right now, with the exception of a handful of larger communications and defense grade providers, have been thinking in terms of nanosatellites, and even SpaceX is talking, you know, tens of thousands of Starlink satellites to be able to kind of complete and expand their network. Uh, there will be a transition period for all that, but I think that the logic of a nanosatellite has been speed and ease to develop, low cost to deploy. You can just hitch a ride with an existing amount of other vehicles going to orbit. In fact, that's become kind of the standard business model now. But with a vehicle this size, with the potential of going into higher orbits relatively cheaply, of being potentially serviceable with a lot of new platforms that are coming online, like what the folks over at Orbit Fab are doing, I could very easily see a shift in the logic of the aerospace industry where nanosatellites don't necessarily go away overnight, but more folks might start crunching the numbers and realize that, oh, I can put a permanent structure in orbit that I don't have to worry about deorbiting, and in fact, service it regularly for less than it costs to put a new vehicle up there to provide more power, more capability, and a longer life cycle. The economics of launch are going to fundamentally change, and that means the economics of satellite development will fundamentally change. And it'd be a really interesting thing if we end up looking back on the nanosatellite era as sort of a transitional period in spaceflight technology, where we go from very large dump truck sized communication satellites to very, very small, very purpose-built vehicles to back up to dump truck or bigger size communication satellites. Interestingly, I think if such a transition did occur, it would necessitate the need for a lot of on-orbit operations that have to go beyond robotics. We might have see the point to where there would have to be space stations whose only function is being a place to, for lack of a better term, bivouac a lot of different on-orbiting research robots, and having to have staff purely to service those robots, and people that have to potentially go out and deal with the satellites themselves.
So we've always had robotics in space, very important. We'll continue to them. Humans are fragile, but we do need humans for certain things. So this is probably a great industry where you can have a lot of complementary use of robotics and humans. But right now, NASA's charging around $130,000 an hour for if you just want to commercially rent an astronaut's time. I don't know if that gets sliced down to 15-minute increments or it's just per hour.
We've looked into this for other projects, folks. This is something that has been this is a very practical question for us, not just a theoretical one.
If you're able also just bring down the price of your on-orbit astronaut to something a lot more reasonable in terms of terrestrial pricing, gets very interesting, because it's probably unreal. Like you're talking about, like we'll go back to the space-based solar power project. It's probably pretty unrealistic that you're going to have like hundreds of technicians building this. You're going to probably need robots when you're talking about something spread out over miles in an array over miles in space, but you wouldn't still need, a certain amount of oversight.
Yeah. And I could easily see, deployability is still going to be an issue. I could very easily see, Redwire Space Systems taking on that task and deploying it, with like a Canadarm type system to where it's being handled, as like an unfurlable solar panel. And it's mostly, just a couple of bolt-on points that take a few hours just because everything has to be done very delicately up there. But yeah, you're still going to need humans for a lot of operations up there. But you said you don't see hundreds of people. I actually do. If we're talking, just because the scalability of how big satellite constellations could get at this point, it's just going to get to a point to where you're going to need a lot of eyes and a lot of hands, even for mostly autonomous operations.
So you would see them going up and spending a week at a time, staying in some sort of space station? What could you imagine for these early, crews that are building this? It's not even a train line. If Starship is part of the train line and they're building these new places, they're, settlements, places to work, operational fields, camps, whatever you want to call them.
Yeah, I could very easily see it being kind of a culture that is sort of a little bit McMurdo Antarctic Station combined with oil rig, where you have just a handful of people stuck on a largely utilitarian vessel for weeks and possibly longer. Who knows? I mean, the name of the game for human spaceflight has always been to develop the logistics and health infrastructure to make it possible for humans to stay in space as long as possible and potentially indefinitely. But yeah, I could see teams going out for a few weeks at a time on work shifts, being assigned to just repair and maintain satellites, either having to go out and capture them directly or having vehicles like a space tug of some kind drag them back to a sheltered work area on the station. I mean, I don't know. We're seeing the beginnings of a whole new not just whole new technologies, but kind of a whole new culture of the space industry, and it will be a bit of a transition. I mean, when we talk about hundreds of technicians, right now, when NASA screens for astronauts, and they're opening it up to more people right now, in fact. But even when they open it up to more people, they are screening for the best of the best of the best of the best of the best. Folks who are like, well, I'm an Air Force colonel with 20,000 hours, in the seat of an F-22, and in my spare time, I'm also an Olympic level athlete, kind of things, and I also have 3 PhDs. So the problem is that's a very small talent pool to pull from. And if we're talking hundreds of people, one of two things has to happen. Either this has to become a far more international community than it currently is, just by pure numbers. The space industry at the moment is America plus Russia and friends. That's just the logic of countries that have the money to put this up. But with a Starship, it becomes a lot cheaper to go into space. Not inexpensive, but a lot cheaper. Cheap enough to where smaller countries that have still a lot of capital and a lot of technology, like South Korea or Australia or Israel or Canada itself, can operate their own space programs, or potentially just have guys hitch a ride to go there on an entirely private flight service, and operate crews a lot more independently. Option B is that you have to look at astronauts less as jack of all trades is the wrong term, because it's more like they're masters of everything. You have to stop looking at astronauts as very, very qualified in multiple disciplines to people who are trained and qualified in one discipline. So in other words, rather than having astronauts be extremely versatile professionals, you have a handful of astronauts who are assigned just to be technicians for satellites, who are purely specialists in the mission at hand.
So it leaves open for folks that do have specialized areas to start thinking about, how could my work potentially intersect, whether it's leveraging the vacuum of space microgravity, other areas like that. Just even if it's just a thought exercise, because who knows, maybe you might be able to, whether you're a researcher or an engineer, develop something that has a novel use case in space or can be derived from being tested in a space environment.
Now, this also presents a new problem, which is one, there is not a lot of kind of the investment and debt infrastructure for financing operations in space has never had to deal with anything on this scale from a lot of the operators who could potentially take advantage of this, like we're talking about. Number two, even if we're talking about specialists for specific operations, the education infrastructure isn't there yet either. NASA is, and eventually Polaris are kind of the only game in town right now, at least in the US, for training people to be astronauts, not just scientists who can hitch a ride into space. So we will have to see an increase in investment to actually developing out training facilities and whatnot to get people experienced in operating in space. I'm sure there will be somebody, this is just the reality of the private sector, someone might try to do this with way too little training at some point in the future. Hopefully the regulatory regime is able to kind of develop itself without becoming overly constraining for how this shift has to happen. This is going to be messy. There's not going to be a clean transition for all this. And it's going to take us a while before we figure out, what's an appropriate level of regulatory burden, what's an appropriate level of training for people who are supposed to just be specialized in one particular discipline for repairing satellites or refueling systems, or just being biotech, technicians who never actually have to conduct EVAs or anything like that. It's going to be a messy transition. But that's what happens every time we see an order of magnitude shift in how an industry operates.
Now, thank you, Keegan. Now, speaking of messy, let's talk about space debris in lower Earth orbit, and space debris can look like a paint chip, or it could be a dead spacecraft. And there's been discussion of how do we mitigate and deal with this? Is this an international regulatory issue, or we need to have kind of a treaty regarding this? There's also operational issue. How do you clean some of this up? And we're just now starting to see we've had just a very few tests on different systems on how you could address this, because there's different ways, everything from pushing it out of the way or pushing it back in to burn up, to actually using some sort of laser to destroy it, which has its own potential challenges. But yeah, let's kind of explore that for a bit, and maybe where Starship fits into this, because we want a clean space environment to operate in, because it's not just about it being cluttered in terms of operational, it's a safety issue.
Oh yeah, and it's been discussed for a long time. I mean, I've been out of school for going on over a decade now, and even on my last year there. Was it my last year, or was I just visiting for something? I can't remember which. There was a senior design program that was exploring, space debris through direct capture of derelict satellites and deorbiting with a kind of little mini tugs. There's been discussion of pushing them out of orbit, like you said, with lasers. That's been the most popular option because it requires a comparatively small vehicle where your power supply is really all you have to worry about. None of the projects have ever even gotten to a deployable test article. Partly because it's always been an issue of unit economics. The problem is there. It has the potential to get worse. It's just never gotten so bad that everyone has to worry about it. I would argue that even with the, we almost hit, order of magnitude scale and number of satellites in orbit right now. It was before Starlink, there was maybe 1,500 operational satellites in orbit at any given time. It's now something like 8,000, I think. Possibly more, changes week to week now. With that much hardware, you'd think the debris risk would have gone up, but actually with the nanosatellite industry, it has it's arguably reduced the debris risk because all these vehicles are designed to burn up after only a year or two. But if we shift to bigger payloads, payloads in higher orbit, that risk goes up in a big way. And ironically, the increase in launch volume, which makes that risk far bigger, makes the economics of doing debris recovery and remediation far more practical. So I think that it will take a little bit. This will probably be something that private sector operation might be able to take a crack at it. If there's enough hardware that's big enough in orbit that could potentially become derelict, you obviously have a greater incentive to not only do on orbit, repairs of these vehicles for, the operators are going to want their lifespans, increased, but you could potentially have enough debris in orbit to where capturing it and recycling it might actually make a degree of sense economically. I think the volume would have to increase to such a degree to make that practical, and we're going to be a few years up from that. And with enough hardware that is big enough in orbit that is doing operations that cover even more customers and potentially become far more economically significant, the Space Force and potentially other international organizations would have that much more incentive to put the money up to defend against space debris, because again, the greater our dependence on space becomes economically, the more incentivized governments are to try to defend those assets and prevent them from being damaged. You don't want a situation to where, Amazon's got its new server farm, it's entirely in orbit. One paint chip that could potentially damage it could shut down internet access for 30 million people or more. That's not a situation anyone wants to go through. And that creates a pretty high incentive for either private companies themselves to do that or for governments to put up the money.
Yeah, and people say, well, how is that going to get paid? If there's probably a will, there is a way at some point. And maybe I could see it eventually, maybe in a long term, if this has to be a long-term government subsidy, a small telecommunications tax. People don't like to hear that, but maybe, I don't know, it's a penny buried into a bill somewhere.
The U.S. defense budget is $850 billion this year, going into fiscal year 2025. I really don't think this is going to be anything more than a line item when it's all said and done. And the Space Force would probably love nothing more than to just add another mission onto their roster. We don't think of this, but the military is fundamentally just a government agency, and there's nothing governments love more than when they're building out a department that might have a lot of critique, than making themselves that much more essential.
So, Keegan, there's been proposed about a version of the Coast Guard, like a space Coast Guard. So with that, so Space Force, it's a little different, but could you see them also having kind of a Coast Guard type of task to their mission?
Yeah, I don't think it would be a separate branch for a little while there. They wouldn't do that unless they felt they were getting overburdened with too many responsibilities. But I could very easily see them adopting a, orbital debris remediation and cleanup role to one degree or another. They might staff most of the actual labor out to a handful of satellites that's only operation is to, track all the debris. NASA already does that to one degree or another. And to be honest, I think the agency, it's not really a question of giving up responsibilities so much as it's going to be, a question of trying to have as much coverage up there as possible.
So for the layman, how do assets and space debris how are they currently tracked? Is it coming from space satellites? Is it coming from the ground? Are they using radar? Is it a combination? Do they have people just with really great, binoculars? How is this? How are they tracking this? Because they talk about these thousands and thousands of pieces that they're able to track, even if when there's an event and the satellites, whether it's from a missile test or a collision. What does this look like?
Well, debris tracking is not an area of expertise of my own. So anything done in space is usually done with degree of scanning lidar. Uh, the ESA has been talking now about building dedicated space debris tracking systems. These would be developed to go after much smaller pieces. NASA is currently able to identify, from their existing infrastructure, specs that are only a few millimeters wide. But we're talking much smaller than that now, going down to I said millimeters, round a couple centimeters. We're now talking about going below that, so less than an inch, really. The ESA itself recently released a report where they're how was this? Yeah, this was from just last fall, where they were tracking something in the neighborhood of 34,600 pieces of space debris fragments from Earth-based radars. Most of these objects are a hair bigger than 4 inches. NASA's got better gear just because it's NASA. They've got the money to put up from this. But scientists estimate that there's something in the neighborhood of around 1 million pieces of space debris that are between 0.4 to 4 inches wide. Now, these are the paint chip size objects that can really do some damage at their present velocities. The ESA estimates that those numbers could actually be, far higher for objects less than 0.4 inches. Potentially, there could be as many as over 130 million pieces of these things. Now, smaller you go, less damage, but not no damage. Oh, we are.
SpaceX is looks like their live stream is starting.
I'm not getting anything yet.
Not yet. Let's just try this again.
And we'll give it a couple of minutes if need be.
I'm going to double check
X. Oh, hang on it. Oh, here we go. Looks like they are live. All right, we'll do.
All right, yeah, I think we're.
And I'm just going to mute that because as much fun as this is, don't want it to completely, well, not mute. I'll reduce the volume a little bit. All right, so, a bunch of glory shots of the previous Starship test articles, minus the few RUDs they've had over the years. Even with what little is being done purely for rocket testing, the scale of production is difficult to overstate. For me, Robert, what's your biggest question mark for today's flight? For me, it's definitely the heat shield tiles. I'll be very curious to see how those perform during reentry.
I don't really have an expectation. I've learned over the years to just not have an expectation. This is a test and it's something that you just but in terms of what I would personally love to see, I think I would love to see, actually land, in the Indian Ocean. I think that would just, it's also a new location on the planet that we don't typically have. I think US providers that I know of ever doing landing tests, South Pacific maybe, yeah, this would be interesting. I'm trying to find out. Let's see here. When we're talking about the number of engines, I think it's like me 33 engines on Starship today.
I believe so, yes, and she can lose quite a few of those. I think like up to a third and still be, flight worthy. 33 odd engines, not counting the vacuum Raptors once they get in orbit. We will see how everything performs. Last time, there was apparently a series of unexplained, I believe it was an engine shutdown or something that caused some issues. That is a fairly resolvable problem. For me, the last flight, the thing I was most worried about was would the hot staging method, was it optimized enough to where there wouldn't have been enough damage to the forward header tanks on the super heavy vehicle? Would there have been any type of thermal shock within the engines themselves, or not thermal shock, hydraulic shock within the engines themselves? They apparently did not have any of that to worry about, which has been very encouraging.
So Keegan, how are these? How is their heat tiles different than what was used in the space shuttle days?
Well, the biggest difference has been manufacturing doctrine. So the space shuttle, very, very slippery, highly tailored design, pseudo blending wing body. Ironically, Starship's movable wings make it more of a blending body than the shuttle is, but I won't get into that detail because we'd be here all day talking about aviation stuff. These are all hexagon shaped tiles, with most of them being custom work. We're seeing right now, I believe, just a video from the previous flights. These tiles can be manufactured at scale, and rather than being, if you've ever seen it, the shuttle each tile had to be manually inserted by a special technician, usually 4 or 5 times, and then like adhered to the machine. And it was a very, very delicate process, whereas SpaceX has achieved with Starship a tile affixing process that is purely mechanical. They still have to have, for lack of a better term, space bondo between each tile to seal everything off. But because they're mass-produced hexagons for the most part, these can be fairly rapidly deployed. Oh, crumb. Are we having some connection issues? Is this this me or
fine? Next to that, we're back. We see it's back.
Okay. Yeah. So mass-produced hexagon tiles mean they can make a bunch of these things, and to fix them and have them be mechanically fixed means that it's a faster and preferably cheaper install method. Now they still have to have custom tiles, particularly around those the actual hinges connecting the
there's still some detail. There's still some detail and cleanup work.
Right.
Okay.
And the tile bakery will, again, if we're talking dozen to potentially dozens of these things being built a year, the tile bakery will eventually get to a point where they can just mass produce these ones and just have them on stock. But this is probably the biggest difference for this vehicle as opposed to the shuttle for me is its lack of a thermal blanket. The shuttle was, white because it was partially because it was covered in kind of a Kevlar high heat thermal blanket that was meant to not only stop heat from the heat shield tiles itself, but any residual heat that might spill over and affect the body of the spacecraft. You can see kind of towards the nose of the vehicle that those hexagon tiles kind of spill over and come up past where the flaps, are. SpaceX has done some very, very detailed thermal modeling to know just where the heat is actually going to travel, and that lets them solve this problem entirely with heat shield tiles in theory. We'll see how she actually handles when the vehicle has to re-enter, if it gets to that phase, knock on wood. But we will indeed see how this machine will be able to handle it. Re-entry is also a little bit different compared to the shuttle. They call it a belly flop re-entry for a lot of reasons, because the shuttle was like a little bit more nose forward as it was coming in, whereas Starship is going to be angled a lot more to where almost all the heat is going to be hitting just the underside of the spacecraft. So that will be able to distribute that heat over a larger area. That's why it has these 4 flaps that are positioned with the 2 smaller flaps towards the aft end, and then far further forward 2 smaller canards, that aren't that much smaller than our forward flaps, to be able to right the vehicle, fold in and act as a lifting body, distributing that heat, from beyond the most of the area of the spacecraft.
Here we've got a little video profile of the planned flight today, and here see Starship flying over roughly South Africa. Now
missing Madagascar and heading right into just short of Indonesia and Australia.
Yeah.
So hopefully, that is indeed what will actually go down. Again, perfect flight today is getting that belly flop in the ocean. Uh, we'll see. We forget, but this is also a test flight for Super Heavy as well. Well, the actual booster. Uh, Perfect situation for that today, I believe, is landing test would be the wrong term. Deceleration test, and then also doing kind of a flop in the ocean where they might hypothetically be able to recover, a sizable portion of the Raptor engines, not really for reuse, but just being able to kind of check them out and see how they, actually performed under the conditions of the flight. Uh, I don't know if SpaceX has given sort of an estimate on when they plan on doing a capture of Super Heavy. I feel like we've all been so tunnel visioned on getting to this to orbit flight that we forget that the the launch infrastructure and indeed the business model of Starship is all based on the fact that the thing is fully reusable, and SpaceX's current plan for all that requires them to capture Super Heavy with those big chopsticks that they currently use to lift the vehicle and assemble everything into place. Nothing even close to that has, the closest possible comparison has been the recovery of the lower stages of the Falcon rockets, but this is a significantly larger spacecraft, burning with a lot more power behind it, and then landing only on land. In fact, that's a thing with the that might have put the kibosh on plans for offshore launches was I think concept art was all based on the idea of also recovering the first stage offshore. I don't think you necessarily have to do that. You could, depending on how you have the thing fly back, you could conceivably have Super Heavy, launch from offshore and then land back on land. It would depend on how far away it was, but you'd need to have like dedicated landing infrastructure separate of all that. So it might end up being a prohibitively expensive infrastructure cost. We'll see how all that goes through. Very curious to see how the orbital refueling aspect of this, flight works today.
And essentially,
this is.
And Keegan, let's share with any of the viewers. They're basically transferring some fuel between tanks. Is that correct? That's the plan.
That's the sound of it. So that doesn't sound that impressive to the layperson, but that's still a pretty big deal. Moving fuel around in microgravity is not something anyone likes to do if they can help it. If you're a fan of a certain space launch video game, it's something you do all the time if you can get away with it. But this is an issue that hasn't really been tested at scale before. So Starship is, if nothing else, a great large-scale platform to be able to test the basics of this. So knock on wood that that also goes through. Today's flight isn't really a test of just one thing. This is essentially at least 3 or 4 different subsystem level tests, and then multiple subsystem level tests beneath all that for in-orbit refueling, the spacecraft, the launch vehicle, the ground system infrastructure. And that's before you tack on the fact that it's, every day is a test of how can we make our, not just stage 0, but the rest of the ground system infrastructure that much more efficient, that's much more reliable. Those are the smaller battles that don't get nearly as much attention, but are very important. Now we have SpaceX still going with this PEZ dispenser model, which admittedly makes a lot of sense for the Starlink program. These would be the Gen 2 Starlink satellites, which are truly enormous. What are we talking here? 8-meter, wide platform. In fact, it's weird that SpaceX has not been willing to talk too much about, in-space solar power, because Starlink's satellites themselves would be kind of ideal initial, small scale test articles to test all this for, at least for Gen 2, because we're talking 8-meter wide. What would it be? Like probably a couple 100 feet long solar panels just to power these things. Truly enormous.
It looks like we've got the it looks like some of the fog is clearing, but you've got a nice overcast day out there in South
Yeah.
Texas.
The natural fog. Fun thing about anything involving a lot of cryogenically cooled propellant is that you make your own as time goes on. Yeah, and
So weather go, range go, vehicle go. Okay, that's looking good.
so far so good. But again, we'll see if just in my own experience being in the field, it's always your day can be ruined by just one tiny thing. Now SpaceX have refined this launch process down to it being it's not even a science anymore. It's beyond academic. It's just it's just work a day now for Falcon. But for Starship, it's still a lot of tests, a lot of things that are being kind of worked out. We'll see if this all goes through. I'm not trying watching. I'm just it's always too important that they're called test flights for a reason.
So since we have a little time here, Keegan, are we gonna do the audio here with the launch? Are we gonna
Oh, I'm gonna shut up and I say we, crank this thing up
once it's once we're maybe within a minute of flight, maybe we'll kind of our 30 seconds mute ourselves and go to the SpaceX audio, and then we can add in some commentary as necessary.
Yep.
Let's just see. Okay, so they've got nice little. So they've got methane. This is kind of an important topic. Why this system is using methane and how it's important for kind of SpaceX's long-term aspirations.
All right. I'll try to explain this as best I can because this is an area where I'm less of an where I'm more informed than the average person, but by no means an expert, because this is when you get in a degree and thermal creep issues with the but short answer is while methane is not as energy dense as hydrogen as your propellant, hydrogen is far less dense when you store it cryogenically. Hydrogen is like closer to its boiling point than it is as as fully as a liquid when it's stored cryogenically. Methane is almost a solid when you store it cryogenically. An advantage of that is because it is able to hold on to much higher densities in those cold temperatures. When you run methane over the engine bell and thermal exchange system to preheat the fuel and cool the engine, you're causing far less creep in the engine, and you're able to achieve much higher temperatures with your motors. So one thing that is just not even talked about anymore that for me was the biggest deal of Starship when it was first proposed, the Raptor is what's called a full flow stage combustion cycle engine. There have been a grand total of 3 of those things ever built. The Soviets came up with one in the 70s, the RD-287 or something like that, I think was what it's called. Don't quote me on that. I'm terrible with the memorization. Pratt & Whitney developed what was called the Integrated Powerhead Demonstrator back in 2001. That never was a true engine put on a launch vehicle. It was really just a test article. And then Raptor, which is the only one that has ever been used on an actual vehicle. Full flow means it's not just an issue of, without getting into a whole bunch of the details, full flow engines can be used for multiple flights far more easily than any other vehicle. The Space Shuttle main engines were just stage combustion cycle engines. Those had to be like swap hauled basically. Raptors at the moment have never really been able to be tested beyond the test stand without being destroyed by just the nature of this type of vehicle's tests. But if they can refine the launch, they can use Raptor multiple times and not have to overhaul them. And a big reason why is because methane is able to be stored so much more densely and transfer for its heat much more efficiently. And there's also a weird phenomenon when it goes into the turbo pumps. It creates like a lot less mechanical shock because it's not trying to transition to a gas so quickly. I think it's a similar again, I'm going to sound really dumb with this. I think it's a similar phenomenon on how cavitation works with like the props of a submarine or a big ship. When you reduce your reduce your pressure, you cause the transition of a liquid to a gas, and that can like screws up kind of how the props, or in this case turbopumps, sort of react with everything and can cause longer term damage. With methane, that's less of a worry. It's also cheaper, easier to store long term, and for much long term, something you can make just using, what is it? It's not. Why am I? My brain is going to the Haber-Bosch process, but that's how you make nitrogen. That's how you make nitrogen fertilizer. There's a relatively simple process that's just 19th century physics to convert carbon dioxide and hydrogen into a source of methane, meaning they can harvest their fuel on the surface of Mars when they get one of these ships that far out. Which, whatever timeline SpaceX is telling you, even if it's backed by NASA, even if they mean it as best they can, just ignore that for the time being. They'll get there when they get there.
Out on the screen, one of the earlier tests. This is
this was IFT 1, I believe. No, this would have been 2, where she went with our silver tea kettle there. Got to the flip for booster 1. Not a small thing to achieve, not for a vehicle that big with that much weight behind it. Got relight for everything, just always really cool seeing all those engines power down and then heat back up again. But yeah, so methane, again, it's my favorite thing about this vehicle in a lot of ways is all the little boring stuff that is all based around SpaceX's commitment to really make Starship all about scalability, more vehicles, less time between launches, just more. So that's kind of the logic that they go into with almost everything with this vehicle's development. And now we have these look like really stripped down prototypes of NASA's next generation suits that they're working on. Interestingly, NASA for years has been trying to pull off these designs that are semi-hard bodies around a largely hard main suit frame. In fact, I believe the last generation or 2 of suits used on the space station have like a hard chest piece, and mostly it's like an advanced Kevlar or something like that for everything else. But the big change everyone always kind of reacts to is they've got these big backpacks on them that are like a refrigerator door, to where the spacecraft can, the suit can just kind of hang on the outside side of the spacecraft, and you just have to climb into that instead of having to go through a traditional, kind of decompression chamber and everything. And the fun part is that is really just a modernized version of the moon suits the Soviets had come up with during their long aborted lunar program back in the 60s, back when it was the N1 and that goofy little one-man lander they were going to use to get to the surface. They wanted to have the suit be something you could just kind of crawl into, and all your logistics would be sort of in this refrigerator door that you would just kind of close behind yourself. Right? I was always confused how they would achieve that with just one person being in there, because you'd have to like slide into the spacecraft, into rather the spacesuit, which is a form of a spacecraft really, and then somehow close the door behind you, and then pop yourself into an armhole before popping out of the spacecraft, out of the vehicle. It seems like you'd need to have an astronaut who is a part-time contortionist to be able to pull that off.
Yeah.
All right, we're getting.
Okay, we're just getting in. Okay, 10 minutes, about 10 minutes and 40 seconds.
Yep.
So Keegan, when will we see this thing topped up with fuel?
Well, you can actually watch it right now. The ice that is moving up the booster stage and the spacecraft itself. Uh, at this point, it's probably more or less being topped up, and then they'll just keep adding and bleeding as necessary. When you're doing with a cryogenically, stored fuel, even with something as efficient as methane, it's just always constantly managing pressure. So they're just going to keep that thing going. But yeah, it's with this spacecraft, because it doesn't have any type of insulating foam on it or anything, you can just watch the ice, trickle its way up as that super cooled methane, makes its way into the tanks. Yeah.
It's nice that SpaceX now has a number of different camera angles going for us today.
Yep.
Really evolved this over the years.
Yeah, and if you're watching any other feed, and why would you if you just wanted to hurt our feelings or something? You'd be getting multiple air cameras. There's probably half the space, half the tank watchers, as they're called, all over the place down there right now, with every camera, with half the high-powered cameras in the Western Hemisphere are probably pointed at this thing.
I think a shout out to my friends Kyle and Ryan, who I think started at the very beginning with SpaceX's first webcasts, and I think they continue to help produce them today.
Well, very good for Kyle and Ryan.
Yeah.
Yeah. All right. The long-term plan, not really long-term, fairly near-term. Personally, I think 2 launch towers is probably a little conservative for what SpaceX eventually wants to go with all of this. Maybe that'll be how it is at Kennedy for a little while there. But I think it's more along the lines of, if you've ever seen the complex from space, it's more like, a few dozen towers spanned over miles for what was used for really the Apollo program and all successive missions. I could see SpaceX taking over more of those and maybe having double sites for each one. But I think, again, the scale of infrastructure that would just be required from a vehicle that can be produced at these rates is truly incalculable, something we just haven't thought of at any level. The biggest mitigating factor will be how much infrastructure can you put in close proximity that can also handle the conditions of the acoustics from this kind of a launch. Well, the upper stage is looking very clean. I don't see, any kind of degradation of the tiles whatsoever.
What would you notice? What would you one be able to notice in terms of that? Any of the changes in the tiles? What?
Well, it's the most common thing tank watchers always spot is a little bit of a bright spot shining through the belly of the vehicle from where a tile fell off. Okay. That was not a serious risk for today, not after 3 test flights and God knows, and 28 vehicles. They've 29 as well, because Ship 29 is also being fielded. SpaceX has refined that to the point to where the risk of a tile just kind of falling off on the pad is not really too big a worry anymore. We will see how well they do during flight. This thing is going to be shaken like crazy after all, and we'll see if any of these things end up just kind of working themselves off of the bracket that is mounting them to the vehicle. There's also the risk that any type of a shock during launch could potentially crack one and cause it to fall off there. Again, the heat shield tiles are my biggest question mark for this whole flight. But we might have another software bug. She might, end up experiencing another RUD, hopefully after separation. SpaceX has apparently identified the problem. The FAA has concurred. They, seem to have largely resolved it. But I will keep saying it. They are called test flights for a reason. Everything today is learning experience.
Again, if you are just joining us, I'm Robert Jacobson, and I'm with Keegan Kirkpatrick. We're Space Advisors, and we also have the podcast Brave New Space, and we're on Twitter at Podcast Brave. It's our Twitter X handle. Excuse me. Use the revision current name X.
And And if you're a company, either a space startup or a company that's never done anything space before, that's looking to leverage, what we've been talking about, new launch volumes, making it easier and cheaper for new companies to come online, that's the kind of consultancy we are. We help companies that are trying to take advantage of the space business who have no prior experience with it whatsoever.
Okay, we're within 5 minutes.
No holds. That's
Yeah.
really encouraging. Again, I remember back when I was working for Mazda Space Systems, who were recently acquired by Astrobotic, you, you were just used to sitting around the desert waiting waiting for the word hold to come in because something was going to interrupt your flight, and that was all flight testing. That was all research. Called it engineering summer camp back in the day, and it was always something small that if you were doing, I was an actual, on-site, LOX loader and vehicle checkout guy, but it was always the guys in the actual shed checking on radio frequencies and all the software stuff that had to that were the ones who were really sweating bullets because they were the ones who had to chase down problems that they couldn't see or touch. And I got a lot of love for people like that who are in the SpaceX, mission control today, because they are the ones who are very acutely aware that while the vehicle might not die because of them, a lot of cameras can be pointing on something that is just sitting there if anything goes wrong. So those guys are often the unsung heroes of missions like this, and they deserve a lot more love than they get. Coming on to 3 minutes. Almost there.
So we might want to also add that, this is at Starbase. They're calling it Starbase. And they've got
formerly Boca Chica, just off of Brownsville, Texas, right there on the U.S.-Mexican border.
And I don't know, probably at any given time, there's probably 2,000 to 4,000 people working there. I don't know, just at SpaceX, I don't know what the current headcount is, but
really tough call. And folks, it's always a question of, okay, who's there semi-permanently, aka out in trailers for a few months out of the year, and who's flying in this week. I've got some friends who are out there who, even comparatively junior level engineers are making flights out to Texas from Hawthorne almost weekly a lot of the time.
Yeah, and I think it's the largest employer in the region.
Oh yeah, I mean, without a doubt. I mean, we're way down on the U.S.-Mexican border. Brownsville is I think a hour drive away at most. And it's, comparatively small town down there. Boca Chica Village itself is tiny. It was a retirement home with, I think, 100 people who were living there before all this got started.
I also want to invite people to go over to spaceadvisors.com. We actually did a little analysis on 10 states that could be kind of breakout states for taking advantage of the space sector in terms of new opportunities and new growth, and not purely just about launch. There's many other opportunities for states and regions to take advantage of the growing space sector. Now we've got on screen, this is at SpaceX headquarters in Hawthorne. They're getting ready, 90 seconds in for launch. They're excited there. There was a nice view of the floor there. I think maybe we should let's turn on the audio.
Yeah, let's turn on the audio and we'll clam up a little bit.
Hey, Keegan, I don't have any audio coming through.
Okay. Oh, no.
Oh.
Remember what I said about radio frequency guys being the unsung heroes? No. Come on. You're killing me here. All right, I'm just going to refresh really quick. All right, we're good. We're good.
Okay, good.
We're good. Crisis averted.
But we don't have any audio, Keegan.
Yep. 20 seconds.
Should I pipe in some audio from somewhere else? I'm not sure if this is going to be synced though.
You can try. I don't know how much time we're going to have. 9, 8, 7, 6, 5, 4, 3, 2, 1. Green light. And she's cleared the pad. Oh, beauty. Burning really good. You can actually see through the plume. All 33 looking really clean so far.
Oh wow.
Those new Hull cameras are gorgeous. All right, she's about to clear 1,000 kph. There she goes. Oh, she's looking really good. No tiles lost yet that I can see. Oh, hang on. I see one on the tip of the lower fin. Hopefully that'll be okay. That's on the top side of the vehicle. Engine's looking good. That might just be frost. Oh, so clean. God, not one loss so far. Oh, she's looking really good.
Booster engines start.
Hey Keegan, I think I'm gonna try to get the audio here. I'm gonna turn on.
There she goes.
The ship into space. Booster will start to do its flip and then move into the boost back burn, setting it up for eventual splashdown in the Gulf of Mexico.
All right, I can hear you okay. Oh, gorgeous. That's looking really good. Oh, I shut down the audio on my end. And Robert, do you still have audio going on yours to the stream?
Say that again, Keegan.
Do you still have audio going to the stream? I shut it down on my end. Okay, just wanted to be sure about that. Yeah. Hopefully everyone can hear that okay. Flip.
No, I was able to get audio through the direct SpaceX stream.
Okay, good. All right. Okay, outer ring engines is off. Still burning inner ring a little bit there. Okay, she pitched over right. They're already doing better than last time. So she's decelerating now, shutting off. Oh, that's interesting. The shutoff's different. They're going like a crescent moon thing. So it goes from like a waning moon kind of deal, or it goes from one side all the way out. That's neat. Haven't seen that before. Starship is pitching up a little bit, just a hair more. Probably she's got all 6 running, sea levels and vacuums. Super Heavy is looking really good. Burning off a little bit of extra pressure, nothing to worry about. Again, that looks like it's definitely a missing tile on the top side of the. Oh, that's on the front of the vehicle. That's towards the forward section of the spacecraft. That might be an issue. We'll see. Again, right now they're doing far better than they did last time. This is looking how it's supposed to. Okay. Still picking up speed on one, and gravity, Super Heavy's feeling that gravity now. She's past 1,500 kilometers per hour. Past 10K pH on the Starship spacecraft. And they have lost the signal. So that means it's on the far side of the planet. Oh, and this is not technically a big deal because it's already done this. We're beyond the Kármán line, about 30 kilometers above the Kármán line. So Starship is in space. Coming up on, she's righting herself. Super Heavy is at 3,000, and she is nearly normal to the surface of the Earth. God, that footage is gorgeous. All right. I can't remember when they said relight will occur.
I think it's happening.
Oh, you can see, those.
It's happening.
Those are like the biggest pieces of titanium in the world. The 4 big grid fins on a Super Heavy. I can't remember how much torque those motors have to, operate, but it's insane that they can stick something that has that much power on a vehicle that size and still not interrupt any of the other systems that it has on board. I mean, those motors are just next to 6 of the most powerful engines ever built and have a hot stage, and they never undergo any kind of significant damage. Okay. She's wobbling a little bit. She's still normal. She's righting herself okay. I think she's just spinning. That's fine. Looks like we only had one engine relight. That's not good. Well, they were always going to lose Super Heavy, but to be honest, I'd call that 95% of what they wanted done. So I say we still call that a success for now. Now, Starship itself still picking up speed, coming up on 20,000 kph, holding steady at 144 kilometers. 44K above the Kármán line, the cutoff from space to Earth. 7 minutes into this flight and no RUD. Oh, that was okay. You can actually see it to the left of your screen, midway the vehicle. Mm-hmm. We've got ourselves a tile. That one looks actually cracked. So that's going to be, we'll see how much of an issue that ends up being. Anybody who remembers the Columbia disaster knows that it doesn't take much. That will be the one that actually, again, it'll be the tiles really near kind of the belly of the vehicle that'll be getting the absolute worst amount of heat. So hopefully that doesn't cause too much trouble. For me, we'll see. And Miko. Starship has shut down her engines. She is in orbit. Well, suborbit.
Keegan, the screen has frozen for me of Starship. Keegan, you there?
All right. We good?
No, did we lose? Is that all the signal?
We're still recording. We have signal.
Okay,
yeah, we're back.
I don't see the screen share. of
Okay, hang on. Let me just reacquire that. That coming through okay?
Yes, now it is. Okay.
All right. Sorry about that, folks. Had a little bit of a RF issue on our own. Okay, Starship is pitching, or rather, is pitched. Venting a little bit of extra gas here and there. You know, it wasn't making its way all the way to orbit, so it's got a little bit extra fuel there. Sitting pretty at 165 kilometers and 26,000 kilometers per hour. Beautiful. Now, I cannot for the life of me remember how long this flight is supposed to actually occur before she re-enters. It's about 90 minutes to go around the whole Earth. Starship is covering maybe 50% of that. So 45-minute flight, maybe. She's also at a lower orbit. So, well, not orbit. Not technically in orbit.
Check.
Those of you just joining us, we are right now watching SpaceX having successfully taken Starship all the way into suborbit.
As we overfly ground stations, and we don't have a ton of those along our trajectory, but as we have video.
Oh, that's the other thing that we haven't mentioned up until this point. She's flying over the southern Indian Ocean. Not a lot of sites out there that have ground stations for signal acquisition. It'll probably be getting most of its signal from the Seychelles and then from Western Australia, which might be a bit of a blackout zone in there. We'll see.
Views or no views, we'll see you back here at T plus 40 minutes.
Door is opening.
And there we just
all right.
PEZ door is open.
So
great.
First test.
One of our test objectives today is to open and close that PEZ door. That's where we will deploy Starlink satellites from in the future. So great news.
Well, hey.
Excuse me. That test objective is already underway. So come back here, stick around till T plus 40 minutes for coverage of Starship's deorbit burn demonstration, followed by its reentry and what is sure to be an exciting splashdown.
Alrighty.
So let's come back in about let's say about 35 minutes.
Yeah, keep the stream going and return to what SpaceX is doing once they are ready to go. So SpaceX has successfully put Starship in orbit. I keep making that mistake. Putting Starship into suborbit. Successfully got Super Heavy to flip, right itself, decel. Only thing we don't have a clear idea of is what happened just before splashdown. It looks like the feed indicated that only one engine relit. That was always a risk. Again, test flights for a reason. We didn't get anywhere near there on the first flight. And I feel like one engine relighting after everything else going right is like 95% of what they were trying to achieve for just that lower stage. In orbit, they have successfully tested, their PEZ dispenser doors. They've gotten the vehicle all the way to space. Right now, cruising. Let's see here, probably over the South Atlantic, getting ready to cross over South Africa, and probably, well, we're into 10 minutes, probably doing it right now, actually. We are now just waiting to see how well it's going to do on reentry, and we have spotted, as far as we can tell with old Mark 1 eyeball here, what looks like at least one heat shield tile on the right forward nacelle. Right forward flap on the connecting area to that, and what looks like a damaged heat shield tile more towards the midsection of the spacecraft, not directly on the belly, but definitely on its right side. We don't have a clear idea of anything on the left on the vehicle just for this far yet. Oops, excuse me. And we will see what that does to the spacecraft on reentry. The tiles were always the thing that I was a little bit worried about the most. I'm not entirely sure. Loss of a tile was always a risk from it just kind of walking itself off of whatever was adhering it to the vehicle. Damage to one. Hopefully they got some camera footage onto that and what the cause was, because one cracking is either didn't bake right, it could have, or rather, this is also just another version of didn't bake right. Mounting brackets could have been wrong, and it could have picked up a weird resonance frequency thing and just broken on that like a tuning fork. We don't know. We'll see.
And what about the refueling part? Is that probably happening right now? Excuse me, the fuel transfer test? That's probably
Yeah, they haven't said yet, I don't think. So that's probably either happening offline or they'll wait until reacquisition of signal to be able to give us some more info about that later. We'll see. But right now, this mission has been, significant improvement on what they've already achieved. It's a big step in the right direction. Right now, they already have a spacecraft that can get to space and potentially deliver hardware. If they did nothing else, made no other iterations under the vehicle's design at all right now, they have something that is usable. But this is SpaceX. They're not going to stop at good enough. It'll be very interested to see just what comes out of the woodwork, what what startups that have been in stealth mode for a long time will decide that today or tomorrow or wherever is a good time to let every people know what they're working on. So yeah, if you're just joining us, SpaceX has had themselves a successful flight, a semi-successful-ish splashdown of Super Heavy, and we are awaiting reacquisition of signal and a successful landing, or rather a successful reentry and hopefully a successful belly flop. We'll see how she does. But in the meantime, Robert, Space Advisors is a company that helps out a lot of folks who are working on companies that tend to be a little outside of the main focus of the aerospace industry, be they new startups or established companies that want to take advantage of opportunities in space that are now more attainable than ever before. What have been kind of the sectors that you've been most excited about that something like Starship could potentially impact?
I think, in terms of physical sciences and biological sciences, in terms of R&D and manufacturing, and we don't really know maybe what we could guess what we would be manufacturing, but there's still a lot of basic research and development that could be done because ISS is kind of maxed out. It takes a while to get there. You might get one flight. So if we're able to create this new operational tempo, getting a much wider variety and veracity of experiments, and then, and as the discoveries unfold, you're going to see energy going into these areas where, to promising areas in terms of, bringing back, bringing this stuff back. I mean, you've seen just a little bit like recently, Varda had a return entry of their capsule, and I think they took some, I want to say it was an HIV drug or something like this, that they had crystals exposed to the exposed in space, or maybe they weren't exposed, but I think they have
they were in microgravity at least.
Yeah, essentially exposed in microgravity, and those changes are permanent. So it's not like they come back and they because you're back on 1G. No, those crystals are changed. So there's a lot of thought that you could use microgravity to help manipulate processes and other areas within biological and physical sciences for benefits here on Earth.
Although it is worth mentioning that the regulatory regime is still getting used to this. Not even getting used to building the road as you drive on it at the moment. Varda had their payload stuck in space for 8 months trying to get approval for reentry. Now, I'm entirely in agreement with you. I think biotech is definitely where this industry can grow the most with the Starship. That seems really turnkey. I could very easily see, before you even have to include astronauts, have, potentially missions where like a company like Varda could deploy multiple capsules and these little micro bioreactors, potentially bigger ones, on board a Starship in one go. Biotech for me is where this business can do the most amount of near-term good. It is, like you said, an industry that is seriously backlogged in its accessibility of what you can research in space, and the demand is very much there. The other sector that I think this vehicle could impact in a big way, I think you mentioned it very briefly, actually, was on-orbit manufacturing. That has been something that has been long sought after. I know Redwire Space Systems has talked about it even when they were made in space. This is something that could affect. There's certain materials that are relatively low volume and high enough cost where you could manufacture them in orbit and recover them and use them for certain bespoke clients. The same logic that goes into cultivating, biological crystalline compounds still applies to non-biological crystalline compounds. So you can make like really, really pure fiber optics, ball bearings, semiconductor wafers are a really popular one. At a level of purity that is not really possible on Earth. And purity and precision in manufacturing and machining is the thing you always pay the most amount of money for to get a level of performance improvement that is, worth paying the money for. So I could very easily see that being a very, very profitable sector for SpaceX. Although the one thing I'll be most interested to see is who's going to operate Starship for the most part going forward. Will it be companies leasing time directly through SpaceX, as has been the tradition for launch companies forever, just buying directly from, the operator is really your launch vehicle, builder? Or could we see, for lack of a better term, private NASAs with their own mission control and whatnot that buy, a couple to a half dozen or maybe even more Starships and just lease those things as a third party, kind of private NASA or space airliner to one degree or another. It's a very new ball game we've got ourselves today.
Let's see where I'm just going to take a quick look. I guess, yep, they're dark at the moment. SpaceX waiting acquisition of signal, so they're.
Yep, we are still waiting on that one.
Um,
I love this. When we logged off, when they had their cutoff, they had 1.9 million viewers. They are now up to 2.7 million viewers just watching a render of Starship spin around a waiting for acquisition of signal. It's a funny business. So yeah, this is going to be interesting going forward. We've talked about how, we keep mentioning that SpaceX and NASA are confident that they can probably get 6 more test flights this year of Starship. The question is, what will those flights be of? Next one will probably be SN29, which is more or less a clone of the current vehicle they've got right now, maybe some iterative improvements. But SpaceX does have at least 2 other vehicles, variants of Starship, that are on the docket to test out. So what do you think, Robert? Do you think we're going to see multiple versions of this existing format of a reusable, cargo stage, or are we going to get that non-reusable upper stage tested next? after SN29. So flight test number 3 probably.
I think the non-reusable.
Yep. I think so too, just because if nothing else, that gives SpaceX a platform to start distributing Starlink satellites.
Starlink, yeah. I mean, that's, so they can
that's
have a nice feedback loop where they're basically continue to, like they do with Falcon, continue to deliver their own product. I mean, this is pretty unique. I mean, that they're able to they're in the telecommunications business, they're in the launch business, they're and probably some areas in between because of all the internal capabilities, since it was a very vertically integrated company.
Yeah, they're probably they might in a roundabout way be one of the biggest steel one of the biggest welding companies in the South Texas area for just the number of people they need to build this dang thing. Yeah, it'll be we'll see. I think non-reusable stage would probably make a lot of sense for test flight number 3. I don't think they're going to put Starlink on test flight number 3, not unless this flight goes very, very well and flight number 2, goes even, integrated test flight number 4 rather goes even better. But they're going to want to make sure that before they put anything that expensive on this vehicle, that they make sure they get it right, going forward. Beyond that, that still leaves us another 4 flights for the year that could potentially go through. So what are we thinking? A pretty even mix of non-reusable versus reusable, favoring one more than the other? And will one of those test flights be to demonstrate some of the systems for the human landing system, the lunar lander that NASA and SpaceX are working on?
Yeah, we've got, well, also, we haven't even mentioned it, but there's this other company that's trying to, I think, potentially get a launch this year, a competitor, Blue Origin.
Competitor.
And United Launch Alliance is for sale, which we're going to hear. So this is interesting triangulation. US government probably wants a second heavy launch capability. I'm going to guess that, like, it's not quite answering what your previous comment, but that Blue is gonna, my personal guess, Blue is gonna acquire United Launch Alliance, and this will just kind of could be an interesting little bit of a additional choreography to the space ecosystem.
Yeah, and we will see what comes next. I mean, not for nothing, one of the downsides of SpaceX conducting everything out in the open and the mob of, for lack of a better term, unpaid media interns that have watched every second of this, promoted it, designed and reverse engineered every element of this spacecraft. Starship is unfortunately a fairly, probably not that hard to reverse engineer at this point. So we'll see how far a lot of these companies that have the cash to put it up are willing to go to make potential copies and clones of their own versions of Starship. We've been doing all the talking so far and all the commentary. Do we have anything coming in from the stream? Comments, questions, etc.?
Let me just take a look. Look, we have our Brave New Space. We're on X at Brave New Space. Excuse me, Podcast Brave. I'm looking at someone else. That's woe is me, Podcast Brave. But our podcast is called Brave New Space. I don't see any comments yet. There was this is our first live stream, I think.
Right. So if we haven't said it yet, please, if you have questions or comments, something you'd like us to get into, feel free to let us know. But until then, we are happy to keep John about what we've got going on. In fact, we aren't sharing the screen at the moment, but SpaceX has cameras inside the shock baffles of the fuel tanks for Starship, and that is apparently replaced their main screen. We're not going to split on that at the moment, but So we've been talking about speculation for this next year's worth of flights. I would like to kind of go back to talk about something that NASA Administrator Bill Nelson had mentioned early 2023, speculating on the prospect of SpaceX attempting a uncrewed lunar demo flight at the end of 2023. The FAA investigation following IFT-1 ended up kind of and later IFT-2 kind of put the kibosh on that. There was just a lot of time when they couldn't conduct any flights at all. But as it looks like they've solved what was the really driving force behind that, which was loss of the ship in atmosphere and loss of the test stand, they can conduct a lot. That's why these 6 flights for the year are, plus IFT-3 are looking very practical. For a flight out to the moon, that might seem. Oh, they've got reacquisition of signal.
Okay, let's
sharing screen.
all right.
Is she? What's going on here?
Turn on the audio here to see.
Yeah, it's just elevator music right
It's
now.
elevator music. Hilarious.
Yeah. Can't tell if. Doesn't look like it's pitching, so it's probably just outgassing. They're just bleeding off excess fuel. She's at 221 kilometers and 26,000 and some odd kilometers per hour. A little bit of ice, floating around the spacecraft. Oh no, it's in a roll. Okay. Yeah, so it's conducting a roll maneuver. Okay. But Bill Nelson suggested in early 2023, SpaceX could actually achieve a flight out, an uncrewed test flight out to the moon. And a lot of folks brush that aside as truly ridiculous with a vehicle that hadn't even made its way to space yet. Now, former senator and indeed former astronaut Bill Nelson wasn't completely wasn't making anything up necessarily on the fly. There is a way to get a Starship all the way to the moon, potentially in 2024. I don't know if they'll actually attempt it. They might play it a little safer, but there is a technique to do it to really just prove that it can be done. You basically would have to turn Starship into a flying gas tank, remove any payload space in the forward section of the vehicle as much as possible to just fill it up with as much fuel as you possibly could. Launch as normal, get her into orbit, burn like hell, possibly having to make a series of very long orbits where you fly a little further out, and then as you fly back into the lowest point in your orbit or your periapsis, you burn a little bit more, and then you fly a little further out. Then you come back down and then burn once again at the lowest point in your periapsis. That allows you to, push the vehicle out as far as possible. And eventually you get to a point you are actually have your orbit past your apoapsis, the highest point in your orbit, past the orbit of the moon. You have to time this all very carefully. When you do that, when the spacecraft actually flies out there, once it reaches that top where you're beyond the orbit of the moon, the sun will actually tug on you just enough to where you can fall back in, timing everything just right to where you line up where the moon is and you actually fall into a semi-stable orbit. Now, if SpaceX wants to just get a vehicle out there to just prove that it can do it and just test everything for what a long mission like that would be, and it would be a long flight, that would be purely a cargo flight, would probably take about 100 days. You could put her in orbit around the moon, and then if they really wanted to impress everybody, and I don't know, and I don't think they would attempt to do this, you could conceivably achieve a landing. Now, landing in this context is more of a controlled crash than anything else. The vehicle will not be usable past this point. You will be putting a big empty gas can on the surface of the moon, because unless they specifically build a version of Starship that is a test article for HLS, and I don't know if they'd want to waste the money on this. This would be that would be a lot. That would be a really, really high risk mission for something that is still being developed. All of that dust that would be all your dust would be kicked up by the lower stage engines. You wouldn't have those super Dracos up top to allow you to land without kicking up a ton of dust. You'd shred the engines on impact. You'd have dry tanks, probably rip the spacecraft to where it's just scrap iron on the surface of the moon. But you could conceivably achieve an uncrewed landing. It is worth mentioning that there has only been one successful uncrewed landing of a commercial vehicle, and that was only a few months ago. Few months? A month. I don't know. Post-COVID time is just weird. But Robert, you had a bit of a connection to that first successful commercial landing on the lunar surface, if I remember correctly, with the Lunar Archive.
Yeah, so we installed the Lunar Library 3 as part of ARC Mission Foundation's goal of helping back up humanity both on and off planets in different parts of the solar system with really long-term libraries. So on the Intuitive Machines lander, Odysseus, we had one of these libraries, which are made of very thin sheets of nickel. And they're able to deposit data both in analog and digital form. So we can literally put millions of pages of information and data in a very small form factor. Part of this, we took we took all sorts of things, including David Copperfield secrets. We had, texts, and all sorts of very wide-ranging amounts of knowledge. And we had a bunch of partners, including the Long Now Foundation. I think the Great Pause, just Wikipedia, a lot of groups you would know of, and some lesser known groups of different sub-libraries that we curated on that. So yeah, that library is successfully on the moon. And I said it's the Lunar Library 3 because the first one is there. It just ended up crashing on the Bereshit. That's the Israeli spacecraft, the program SpaceX's, which had a hard landing / crash. So the library is probably there. Just where it is probably that would be somebody no one knows.
Might be, it might be there, 5 miles away from the landing site in a pile of dust that someone will uncover in 2,000 years. Who knows?
Yeah, and if it's broken apart, it would be like broken pottery shards. So there's probably still useful data that somebody could pull off that first library. The second library ended up being on Astrobotic's Peregrine mission. That did fly around the moon, but ended up, I think, tanking somewhere in the over the Pacific Ocean.
Yeah, that was a bummer. But and this project is actually a lesser known but still very important problem that Starship can help solve.
Coverage of our third Starship flight test, which lifted off from Starbase, Texas at 8:25
I am going to just
time. Our main objective today was to.
I'm just going to mute that audio because I don't want to be stealing anybody's commentary for the time being. But putting a data storage on the moon might seem a little odd to your average person, but it's actually something that the National Security Administration, multiple private companies, and the Defense Department have all talked about as being a really interesting opportunity for extremely robust data storage. In short, it's really, if the US was under, or any potential private company or international partner were ever under a major cyber attack, something that knocked out a sizable portion of, say, financial records, healthcare records, any of the stuff that we just have sitting in digital storage, having a backup in a place that said cyber attack could not readily reach would be very, very beneficial for any type of internal security. So, I don't know how quickly such a program would be put into practice. There's a lot of attempted lunar missions going on this year and in for the foreseeable future, just from before Starship is even factored in. So it's possible we could see future lunar libraries and other attempts from different companies to try to take advantage of this opportunity and allow certain information from either government contractors or possibly even there's always the possibility of a super angel out there who wants his DNA chain to be stored in data on the lunar surface for a gazillion years, potentially paying for all that. To be the more attempts to try to make a lunar library, to not make a lunar library, but rather to scale up a lunar library that is already begun with the good folks over at Arch Mission. So
yeah, and
interesting
there's
opportunity.
a commercial partner that we've talked with that actually was also on the Intuitive Flights machine called Lone Star Lunar, and their vision is to have kind of dynamic data storage on the moon, where I guess you could safeguard whether it's for financial, governments, really whatever.
Yeah, given the not prevalence, awareness people now have of the risk of cyber attacks and digital manipulation, that degree of security is something that definitely has a greater need than ever before. So
up on about 41 minutes past the
yep,
launch.
which they're back. They're still waiting for reacquisition of signal, probably in the next 4 minutes or so. I mean, this thing is screaming. It should. It's going to be like as it kind of crests the horizon within sight of Australia is probably when they'll get data reacquisition. If I, not for nothing, but if I was France, they have that slightly larger island in the far south of the Indian Ocean, French Antarctic territory. I might want to consider standing up some ground system infrastructure down there for the ESA. That'd be something that this industry could probably use, given just the number of orbits that are covering so much of the Earth now.
Well, it's almost just as impressive that this flight happened as planned, essentially, with very, within a couple hours, and at really the first attempt.
Yeah, folks, if you've sat in on any IFT flights before from SpaceX, any Starship tests at all, the fact they did it day of, no holds, much less any interruptions, is crazy. It is so rare for Mother Nature and your radio frequency stuff and your software stuff and mechanical stuff to all just cooperate like that in one go. And SpaceX is now down below 130 kilometers. The vehicle has pitched, kind of belly first. Let's see here. We are staring from the forward section of the vehicle down by the looks of it. So I had that backwards when we were doing that before. So that chip is on the bottom side of the spacecraft, rather near the aft right wing. No, aft left wing. My right, the spacecraft's left. I think. Yeah, that would have to make sense because the fin is like sloping down. You can kind of see it. Or possibly I'm wrong. It's kind of hard to tell actually from this angle. So probably would, we'll see. She's in a bit of a spin right now. Probably just moving around to make sure that everything's going to be lining up once they start hitting that atmosphere. That'll be once they fall below about 100 kilometers. All right, that looks like rotation is slowing. RCS systems are, cooling off a little bit. And that, my geography is worth a darn. Looks like they are passing just by. That would be the island of Sumatra or possibly Java. I can't really tell with from the angle they're at, but looks like they're getting there. She's pitching back up a little bit, getting ready. She's going to do that burn to slow it down before going into a full reentry. Oh, it looks like they're testing the flaps. Oh. Flaps are moving into position for reentry. So, just a little bit of basic aerodynamics. When you're coming in at beyond 25,000 kilometers per hour, what you were really essentially trying to do is to get the atmosphere to kind of hit you enough to slow down, but still fall off of you. And if those flaps were straight out, the force of impact would shear them off after a certain point. And then you're going ass over tea kettle, and loss of spacecraft is pretty much guaranteed. We are at 108 kilometers above the surface. Again, really going to be interested to see how those tiles hold up, particularly the what we can tell is at least one damaged one and one lost one.
I'm just going to turn on the little audio just to hear what SpaceX. Oh, they still have.
Oh, I've got audio share on mine. I'll kick that back up right now.
Okay.
T plus 49 minutes. So we're getting pretty close here.
And
all right, 49 minutes
here,
is when
it looks like the vehicle is sort of moving back and forth. Part of what you're also seeing is one of the cameras, this onboard view that we have, is on the end of a flap. Starship has front flaps and rear flaps in the vehicle. So we've got 4 of those.
Oh.
And, oh man, we can see the heating on those flaps.
Already
as we're starting
glowing.
To re-enter the Earth's atmosphere. This is where the Earth's atmosphere is doing the work to slow us down.
All right.
And like we said, this plasma field
that's amazing.
So she's just adjusting those flaps. Right now, it's just kissing the top of the atmosphere a little bit.
We're hoping that the plasma field doesn't entirely blanket the entire vehicle. Right now,
And better, because it looks like they've got some damaged tiles.
Brought to you by Starlink.
Yeah, the Starlinks are still communicating and still
Right yourself.
capturing the data and the video that we see here. I mean, Shiva, this is just absolutely incredible views. We've never seen anything like this before.
That
This
might
is
be a damaged
the
one
biggest
on her
flying
belly.
object ever in space.
Absolutely, Kate. And,
All right.
and it's important
Watch
to
those
note
holes
with
really
the
quick,
ascent burn
carefully.
that we did was to get us to orbital velocities, even though we were on a nearly orbital trajectory. So the heating and the loads that Starship is going through right now are what it would be getting.
That
if
good?
we were recovering from
Did
an
something
orbital
good happen?
mission.
She
just the fact
pitched
that we have
backwards a bit
used
there.
reentry, this is incredible.
Yeah. Again, this is the furthest and fastest.
We're going to lose the camera just because if it's on the wingtip, it's not going to survive the heat.
And you can definitely tell by the crowd here in Hawthorne.
The heat shield tiles doing their work. We talked about it earlier. Up to 2,600 degrees Fahrenheit that those heat shield tiles are
backwards and
dissipating
flipping over
as
by
we
the
are
looks of it.
re-entering.
Yeah, now this was one of the critical, or rather the key mission objectives that we were hoping to hit today.
We're below
we have
atmosphere.
Never, like I said before, this is the
hasn't burnt
fastest
up
and
yet.
furthest that Starship has ever flown.
Oh, look at
so
that
this
plasma.
is the first time that we're getting to collect this re-entry data and understand how these 18,000
All right.
hexagonal heat
Watch
shield
the
tiles
speed.
are
She's
working
dropping
together
off
to
really fast
protect
now.
the belly of Starship
Not really fast,
as
it's
it
just
re-enters
starting.
the Earth's atmosphere. Once again, the
at these
atmosphere is
altitudes,
doing us a big favor here by
air is like the molecules of atmosphere
the
are like
atmosphere is actually
feet
doing us
apart.
a huge favor here by acting as a braking system for Starship as it re-enters the atmosphere.
And that's part of the reason why
No,
the
I think-
flaps
yeah,
are so important.
there we go.
We're using
Oh, no,
the
she's-
body of
still
Starship
getting something.
and the drag from the atmosphere to slow us down from orbital speed.
Damn, that camera is
but
holding
you
up
want the vehicle to
shockingly
remain
well
stable.
for something
you want
going
those
through
heat
this.
shield tiles pointed down. So they can absorb the heat of the Earth's atmosphere.
Jeez. Okay, it's righting itself
and so
again.
that's the purpose that they are serving during the hypersonic phase and then again during the subsonic phase.
Absolutely. So like we said,
We
these
getting
views
signal
are being
again?
provided by a couple
Probably
Starlink
not.
terminals that are positioned
Ooh.
on Starship itself. As that plasma builds,
Whoa.
we're hoping that we can bring these views back to you.
She's
But
dancing
you can
around.
see the telemetry there on the right-hand side of your screen. If you watch watch closely, you can see
Now,
the
this
speed
was-
decelerating. Again, that's the
If
friction.
I seem nervous about this, it's
of
really
the
just because I
atmosphere
want the
resulting in this
spacecraft to,
plasma
make its
field,
all the
or
way to the
excuse me,
surface,
blanket,
but they were never
that
going to get,
is,
you know,
potentially blocking the Starlink terminals right
a
now. So we'll
completely
bring those views
smooth
back to you
re-entry
if
no
we
matter
get
what.
them.
They're still
But
working to
right now, for
refine
those
all
of you that
to
have
make sure
recently
that the
joined,
flaps
Starship is
can
currently
manipulate themselves enough to keep
re-entering
the spacecraft
Earth's
right.
atmosphere. This is super exciting because it's the furthest and fastest that Starship has
Holding
ever flown.
pretty
It's just
normal right
absolutely
now.
incredible. Major test milestone, something we wanted to accomplish on flight
Do
2.
you want to maybe lower
Getting to
the
it today,
audio?
So just
Yeah, we'll mute that a little bit.
Okay.
Right now,
Now, we actually
I
have some heat shields here, so
appreciate the
these
commentary
are
from
what's
SpaceX,
doing
but
all
right
the
now
work
I'm
on
far more
Starship
interested on
right
really
now.
just that one little
There
image
are
in the bottom
18,000
there to see
hexagonal,
how the
heat
spacecraft's
shields
doing.
like these.
Uh,
So this one that
they
I have is flat.
Oh.
This is what would be positioned on the
That's interesting.
flaps of Starship, whereas Shell
the
has something
altitude
different.
has stopped changing,
yeah,
and so is the
one I
speed.
have would be on the curved surfaces.
Hmm.
I'll just put it in frame
They haven't
here.
said
So we've
anything,
got
but that
these attached
sounds
points
like
around
to
the
me
vehicle,
that
like you
they.
said, Kate.
Well,
Each
no,
vehicle
silly me.
around
Oh, we got data.
doing the work to make sure that the
We're
structure of the
what is
vehicle
it?
doesn't
4
break
minutes
that
of
thermal
terror
load.
or something like
So
that.
we can
The
recover the vehicles eventually and get to
3-4
that
minutes
safe zone.
going through the
They're
atmosphere,
really
they can't
lightweight.
acquire a signal.
They sound a little different than I would have expected them to, but they are ceramic,
Yep.
and these are what's helping Starship survive through this period of entry. We're not sure how far we're going to make it. Again, this is the furthest that we've gotten in our test flight, but
Gonna be
the
a
further
few
we
minutes
fly,
of
the
just,
more data that
you
we
know,
can get, and that's ultimately
being
how
very,
much
very
success
nervous
there, which
as the
I
spacecraft
think
makes its
today
way
has
through the
been a
atmosphere.
huge
And
success given where
we'll see.
where we've gone and how much further
I don't
we've
even
gotten,
know if they
both
have anything on the
booster
ground
and
to,
Starship
you
itself.
know, watch for a possible, you know, breakup of the vehicle. If it dies, they might just have, you know, go past the reentry phase and have just have to get that image from data.
Throughout the entry period, which is normally something we have to wait for until after splashdown when we get that data off the data recorders.
Yeah.
Mhm.
Now, you mentioned before the flaps, again, that the flaps are protected by the flat heat shields like I have.
Mhm.
There are 4 of those positioned on Starship, 2 at the forward end or the top end, and 2 at the bottom or aft end. And they operate independently to aerodynamically control the vehicle's attitude,
Which
or positioning
we'll see how well they
during
do.
atmospheric flight and
They're
enable precise landing at the
This is a
end.
very different form of
Today, we are
reentry than anyone's ever
attempting
achieved
to splash
before.
down, in the Indian Ocean, and
You know,
we're
the
hoping
shuttle
that we can make it
really
that
didn't
far,
have a
but
lot of surface control at all when it
regardless,
came
is
in.
an
It was,
exciting
you know,
end to what has
the
been an
joke was
exciting
always it was a
day.
flying brick on approach.
Absolutely. And I mean, we've had some tests in the past. We had suborbital campaigns where we have tested out.
And we'll
the
see
aerodynamic
exactly how well
flaps
this
at
vehicle
subsonic
handles
speeds,
this
so
type
that's
of reentry.
below the speed of sound. At hypersonic speeds, well, supersonic speeds first, so faster than the speed of sound, and then hypersonic speeds, so that's more than 5 times the speed of sound.
The thing that's really going to be interesting to me going forward, and this is going to be years before this is ever talked about, is if they're talking seriously about point-to-point travel, will they want it to be
And that's actually a great point,
a
'cause
vertical
we are
landing the
expecting,
entire time, or will they
that
ever
entry
talk at
subsonic
all about the
period to
prospect
occur
of
around T+1
any type of
hour,
powered
and
horizontal
3.5
descent
minutes. So
like they
we're not
did with
there
the shuttle?
yet. We're about 10
Or
minutes
rather,
away
like how,
from that
or
point.
rather,
So
like
again,
how
that
they
is
did with the
when
Buran,
Starship would be
the Soviet
traveling
copy
slower
of
than
the
speed of
American
sound
shuttle.
thanks
Well,
to,
semi-copy. The
atmospheric
Buran had
braking system.
was almost identical to the U.S. shuttle, except for the fact that it had 2 tiny little jet engines on the external section of it, so it could technically fly like a normal airplane rather than, you know, go through be a flying brick on approach, a controlled crash. So we'll see. I don't think SpaceX would be in any hurry to add an extra propulsion system onto this vehicle, but there are, if they made a purely Earth-to-Earth version, who knows? But all right, we're just gonna mute the SpaceX team entirely, because right now it's just us it's our speculation talking over their speculation, and that's no fun for anyone. So we are waiting for reacquisition of signal. Clock is running is about to eclipse 54 minutes. So far, this again, no, if you're just joining us, we really want to drive home that if nothing else goes right beyond this point, if the vehicle burns up on reentry and crashes into a gazillion pieces into the Indian Ocean, this flight has still been a success because SpaceX has gotten the full vehicle all the way to suborbit. That means they have a spacecraft that can deliver payload. And if they achieve nothing else, they have developed a super heavy, high volume, high launch cadence launch vehicle, and nothing like that has ever existed before. So this is already a big win for the aerospace industry. So, Robert, what are you thinking? We gonna get a gentle crash into the surface of the Indian Ocean, or break up into a gazillion pieces, kind of thing right now?
I don't know. The way they've been hitting the check boxes, maybe they'll get the belly flop. Oh wait,
no, I got overexcited for a minute there too. They still haven't heard anything back yet by the looks of it. Yeah. I'm gonna have sound just be on kind of my end and stop the oh shoot, I didn't want to stop share completely. Okay, I'm gonna share that. Then I'm gonna just turn off share sound. That way I can have that a little bit in the back. Wait a minute, that's not. No, that's. All right, that way if they have any news, I can have that without interrupting anything else.
Okay. Yeah, I think they could go with touch the ocean, in one piece. That's where I'm.
Yeah, I mean, it's possible. I'm really nervous about those damaged heat shield tiles, though. I mean, it only took a relatively small chunk of the wingtip of the shuttle to burn through from just the friction of the atmosphere to, kill that vehicle. Yeah, we're coming up. Oh, dang, I should have scratched it down. I completely lost track of when loss of signal occurred to when we are now. It's also a longer reentry a little bit. So we will indeed see if it will actually, be only a 3-minute reentry phase.
Well, I think we're beyond that. You maybe want to turn on the VOM. Let's hear it, SpaceX.
Yeah, let's see. Right now, it sounds like it's just speculation. So, dang it! Sorry, folks. That's me going for the wrong thing. Come on, there we go. Where is it?
Of a landing burn and upright landing. But on the moon, there is no atmosphere. On Mars, the atmosphere is extremely
right now,
thin,
mainly just
so you actually
speculation
need
and promoting
some other sophisticated techniques.
The company's
that other
long-term
landers
plans
have
are.
used to land there.
What
And
else
so
is there to talk about? I mean, that's what we
vertical
do
landing
when we're
is really
doing this
important
kind
to
of thing.
landing on destinations like those, which is ultimately where we're trying to go.
Yeah, absolutely.
Mission
So
controls
we hope to
guys are,
demonstrate,
and
that landing in
doing their
future
best
missions.
to
That wasn't one of
try
our
to
objectives
get a signal
for
into
today.
this thing, but
We wanted the ship to focus on opening.
yeah, that's the
and
downside of
closing,
crashing her
the
into
first
a relatively
demonstration of
completely
opening and
vacant
closing
part of the
PEZ
ocean is
door,
that
which is where
there's
we will deploy Starlink
there's no one to be able to get eyes on it.
As well as
during a Apollo 13 splashdown, they had a whole battle group out there keeping an eye on the sky to see if the capsule had made its way through the atmosphere.
So overall,
and of course the shuttle landed on a runway, so anybody can see that. Whereas this, we're all just stuck waiting for a reacquisition of signal.
High altitude tests allow us to see what those will look like in the future, but this piece that we're doing today of, okay, if we are coming back from orbital velocity and we're going through that entry period, that is the missing piece, right? We already figured out how to land once the ship gets to a certain velocity or altitude. And
that's a really good point.
That we were trying to figure
is that
out
all
today,
prior tests to this point have proved that they can land horizontally from a horizontal
hope to
belly
find
flop
out
to a
soon.
vertical
Yeah,
position.
we talked
They've
about
just never
rapid
gone through the first part of that,
iteration
which
and
is
how
going
we
through
do
reentry.
design. Part of our philosophy is testing early and
The-
often and trying
in
to test
a way, is a
that
whole
is
different
as
subsystem.
flight-like as possible.
Tiles themselves.
But there's only so much you can do in a chamber where you're trying to
A
simulate.
laboratory. All right, we're
coming up on an hour.
Exactly, in a laboratory.
Excuse me.
So there's nothing quite like when the heat shield tile hits the atmosphere
Right.
in flight to gather that wonderful data.
Yeah.
And prove out some of the analyses and probably teach us a bunch of things that we didn't quite get
Yeah,
right.
for sure. And obviously, for those of you that have been watching along with us, those were incredible views to see of that entry period where we
All
saw the heat generating.
Hey, they still don't know.
as the
No, they're still
building
stalling
of
for time.
Starship was,
They're,
making contact with the Earth's atmosphere, and that resulted in some plasma. So as Dan said before,
Not
we
a
believe
peep
that
out
we're
of
in
mission
a bit of a
control yet,
blackout
so they're just
period,
working the problem.
At the moment, we are expecting the vehicle, if it's still alive, we would be expecting the vehicle to be approaching subsonic or slower than the speed of sound speeds in 3.5 minutes from now. So if it's still there in one piece, it still has a way
Okay.
to go. We're not there just yet, but we saw that plasma field building up
all right,
around the
all right.
exterior.
So yeah,
which
it's
can
they don't
blend in
have
the entire
signal
vehicle
acquisition
as
until
it
they
does
get
with
below
all of our
subsonic,
tracking
is what it
missions,
sounds like.
and, we're at a
So
loss for
that's a little
explanations
odd,
at that
to be
point in
honest.
time.
So Dan's seen a lot of those
Hypersonic
with,
is all,
with
when
Dragon
you're
missions
moving
that he's
past Mach
supported.
5
Absolutely.
through the upper atmosphere. And
And we are hearing through some of the telemetry that we did. It did look like we lost Starlink and our TDRS data flow at the exact same time. Now, if both of those signals are cutting out at the exact same time, that could mean we lost the ship. It has been several minutes since we've gotten any data from Starship. We are waiting just a couple more minutes just to see if we can get any additional confirmation, but that is one data point that we're tracking, and that could indicate that we had a loss or a breakup of the ship during that reentry. So might not make it all the way to splashdown today, but we were able to get through the early phases of reentry, hit some of that peak heating,
so yeah,
which
we're
was just really incredible to see a Starship
we
coming
are
back from space after getting all those views from space
going to be
for the
waiting
very first
until
time.
103,
So
give or
we'll
take.
We'll just keep on listening in
on
the loops
the
here, see
clock.
we hear
If
anything
we don't hear
over
anything
the
from
next
then,
couple of minutes,
SpaceX is saying that
and
probably
might
means
bring
ship
a
broke
close
up.
to a pretty successful
If
day
they
so
lost
far.
both sources of
So,
telemetry
again, we did
telemetry
lose
data,
the
like you
TDRS,
said,
that's the
not
tracking
looking
and
too
data
good.
relay satellite. That's the satellite
But
system that
still,
pretty much every
reentry was
spacecraft
not
operating in
required
orbit
for a
right
completely
now,
successful
will
test. This
use
was
to get
already a
data.
big deal.
We were able to get some signal through that, and then.
So if
we
you're
were
just
also
joining us
getting
towards the
data
end
back
here,
through Starlink.
SpaceX has gotten a vehicle,
View
all the
here
way to
of,
suborbit,
mission
delivered a spacecraft
control
all the way
down
into
at
space,
Starbase. So these
made
are
its
all
way
the
at least
folks
to
who are,
the beginning of
experts
reentry.
on the
We'll
various
see how
different
she
systems, taking a
ultimately
look at
shakes
the
out.
live data that we did have.
But this was a banner
Probably
day for the
in
space
mission
industry.
mode still,
Yeah,
but
absolutely.
it would be so tough to stay focused.
You know,
with what an exciting day we've had today.
Yeah.
Yeah, there's no other way
I'm
to
not
say
dead
how
yet.
exciting this is, because this
We
means
don't
SpaceX
know.
already
As
has
Dan
developed
said,
a
we
super
did
heavy,
lose connection with TDRS,
orbit
which is
capable
the
launch
tracking
vehicle.
and data relay satellite
Even if not
system,
reusable,
and Starlink at the same
even
time.
if
So
something that
it
is
a
purely for just
realistic
delivering payload,
possibility that we
that's
lost
huge.
Starship, which
250
honestly
tons
was
to
always
orbit
on the
is
table.
just
We
a
didn't know
truly
how far it was gonna get.
insane amount of
The
mass.
further we could fly and the more data
And
we could collect was
so
always
the next 30
biggest
seconds
win.
here,
And so
we will, 20
regardless
seconds,
of,
we will
if
find
did
out.
lose the vehicle and we are not able to
Oh.
make it all the way to our intended splashdown. Note that we weren't intending to recover this vehicle, either vehicle, the
sounds
Super
like
Heavy
they just
booster,
said that they
nor
did lose the vehicle.
the Starship. We weren't intending to recover either of them. They were both going to basically hit at terminal velocity and break up upon contact with the surface of the ocean. So we're standing by to hear whether or not we are going to be able to get telemetry readings back, but we are possibly anticipating news that we lost Starship due to basically a double blackout from TDRS and Starship, or excuse me, Starship data at the same time.
So
But this is, it's worth mentioning, this is the first time that we have come back at these speeds.
Absolutely.
in
all right,
any of the
so
test flights that we've
fairly
done so
confident
far
that
with
the
Starship.
vehicle
So we are
did
trying
not
to prove
make
out
it,
that the
is
heat
what it
shield
sounds like.
works as intended, that the
Not a huge
controllability of
shocker.
this focus on the speeds, works as
again, those
intended.
heat shield
So
tiles
if we
are,
were able to get
you
back
know,
any data on
killed
that,
one
that
space
means the next
shuttle.
version, what happens on
If
flight 4, 5,
NASA
6,
was going to
is
struggle
gonna
with
be
this, then a
better.
private company sure as hell
We
is
must
going
be
to.
able to get some because
But
we saw
they are
we saw
called test flights for a reason,
incredibly
and I'm
gorgeous
sure they'll
high-definition
figure
views,
out a way to be able to
of
resolve
that
this at
entry
some point.
period whenever it was initially starting. So we
But
must have gotten some data
Today
there.
has been otherwise
Right.
a phenomenal
Well,
day.
it was
Liftoff on time, full ignition.
awesome morning to
Successful
experience
staging,
and seeing
took it from there.
this
Yeah,
integrated
absolutely.
flight test
We
number 3.
were able to see
Yep.
the ship
And
actually
SpaceX
make it
continues
further, as
to
well as the
improve
booster. We
with
were hoping
each
that the
flight
booster would.
or each test.
And always fun to be able to just get together and, you know, witness something new in the space business and share ideas about, you know, what it is we work with our consultant clients and what we work on with our strategic forecasting wing over at Space Advisors. If you're interested in what we do, you can head over to spaceadvisors.com. We are always, you know, ready and willing to help new clients to be able to take advantage of this revolution that is happening in the aerospace business. So
I think
Sure.
Exactly.
And we also hit a
I
number
think it
of
sounds
other...
like, you know, they lost the spacecraft, but it was definitely a successful flight test.
Yep.
So I think we will probably end the live stream shortly. Let's just see here.
I had a friend of mine over the other day. I think I had his Twitter feed up.
All right. Let's see.
So
I'm going to.
Yeah, we are. We are witness to a pretty good day, all things considered, for the aerospace industry. It's a rare thing to be able to see a vehicle like this to begin with, much less once get this far in its development. And we've got 6 more test flights planned for the year. Yeah, it's a pretty significant day, all things considered. And I guess I should give a shout out to my buddy Sean, who, as it turned out, came over and we were working on something. I don't know why he had to sign on to his Twitter feed, but I guess we were end up using his the whole time. So it's like a map making guy on the side. Sean McKnight is technically an alias, so if you like his stuff, look him up, I guess. He has actually helped us out with some design work in the past, pro bono, because he's either a good guy or someone who doesn't know what he's worth, and has done some design work for a white paper that Space Advisors will be releasing in hopefully very soon. So, which will be all about a lot of the stuff we've talked about today.
And so I think we'll wrap up the live stream. Want to thank those who've caught this live or are catching a recording of it. You can find us at spaceadvisors.com and on X. We're Podcast Brave. All right. Well, I'm going to wrap up the live stream just a second. Again, I'm Robert Jacobson, and I'm with Keegan Kirkpatrick.